All right, my ninja warriors, welcome to yet another power packed session. And today's session, I was getting a lot of chats, I was getting a lot of comments that, ma'am, when AOD part 2. So, let me tell you that today's session is going to be all about increasing or decreasing function, number one, and number two is maxima and minima. And if you talk about application of derivative, today's session is going to be most important session as far as your JEE main and advanced is concerned, because mostly I would say majority 99% question will come from this today's session. Okay, all right, and I can see the chat over here. Hi Real English, how are you? Hi Gauri, how are you? All right, thank you Konda. Okay, you guys are wishing me Teachers Day. Thank you so much. Thank you, Gauri. Shalem. Good evening, Shalem. Good evening, Dhanush. Thank you. Thank you, Dhanush. Yes, Raghu, we are having indefinite integration because you guys are spamming a lot for indefinite integration as well. So that's why I had no other option. And I thought, let's just give it a shot on Sunday because you guys are like left, right, and center spamming the whole chat. When is indefinite integration? When is indefinite integration? Okay. All right. Yes. So I can see. All right. Yes. A student is saying, ma'am, I am asking you in so many times, but you didn't replying. What are you trying to ask? I don't understand. Ask me again one more time. Video is not visible, Gauri. No. Video is visible. Refresh. Video is visible, na? Hold on, video is visible, Gauri. What happened? Okay, video is visible, no? I guess video is visible. Then we have, okay, so audible, visible, right? All right. Thank you, Uday. Hi, Uday. Hi, Nitin. All right. Integration is on already. Video is not proper. What happened with the video? Just tell me. Hold on. Any issue with the video? Oh, I guess video is fine. No? Video is fine. Video is fine. Video, to me, video looks absolutely fine. What about others? Gauri is saying that video is not fine. What about others? Are you able to see me? Are you able to hear me? Okay. Hi, Namita. Thank you. Now, okay. All right. Thank you, Athar. All right. So today's session is going to be maxima and minima and increasing and decreasing function. That is, we also call it as monotonicity. Okay. So trust me, today's session is going to be, you're going to love today's session. Okay. Because all the misconceptions regarding application of derivative, because some students are scared of this chapter. Ma'am, we don't understand when to calculate f dash x, when to put f dash x equals to 0, when to calculate f double dash x. It's so much confusing, okay? So in today's session, we are going to clear all the confusions as well, right? Okay. Are we ready? Thank you. So many wishes today. Kya baat hai? Very nice. All right, yes, one student is asking, ma'am, today you teach increasing and decreasing function. I get confused in this topic. Please make it easy. Yes, that's why I'm saying today's session is like confusion clearer session. Today's session is going to be that, okay? All right, yes, clear. Chalo, let's start. Hai? So we are going to, arre, what happened? I'm not able to write. Hold on, what happened? Okay, maybe enable editing, slideshow from the beginning. Perfect. Yes, okay. All right. So for all of those who are new to the channel and new to my session, this is my brief introduction. My name is Namrata and I have over more than 10 years of teaching experience in both online and offline. These are my credentials and I have got various selection in top IITs, NITs and various other reputed colleges as well. Okay. So duration of this session is going to be like 3 to 4 hours. Okay. Or let's see before that if we are able to finish it off. Okay. All right. Chalo, let's start. I can't find the remote. Okay, remote is here. Okay. So two topics we are going to focus today. First one will be monotonicity. Monotonicity. This is the first topic. This is something which you always call it as increasing or decreasing function. Okay, first. Second will be maxima minima. Okay, both are obviously interrelated. If you understand monotonicity nicely, then understanding maxima and minima will be a cakewalk for you. Okay, so pay attention while I teach you monotonicity, and then once you are done with once you are done with this, maxima minima, automatically you will be like, okay, just like a few things and you are done, dusted. Okay, all right, clear? Chalo, monotonicity. Monotonicity. Okay, so monotonous, have you ever heard this word monotonous? Have you ever have you ever told your friend that you are being monotonous? Can anybody tell me in the chat box, what does the word monotonous means? So monotonous means boring, or boring, rather boring, I would say. Monotonous is predictable, right? It is going on the same tangent. There is no fluctuation, there is no variation. So that's why we call it as monotonous. Okay? And to monotonous, if you Google this word has a meaning. That means a predictability. This is going to be same. Like in future also it is going to be same. Okay? Alright. Yes. So what is monotonous function? Monotonic function. So our function is said to be monotonic function if they are either increasing or decreasing. Okay, all right. So two types of functions are called as monotonous. What are those two types? Increasing or decreasing. Either increasing, this is or decreasing. Okay, all right, clear? Just say, for example, let me just give you some example. Exponential function. Do you remember the graph of exponential function? By the way, we have studied this in functions chapter. Okay, so I have taught you functions chapter wherein I taught you the graph of exponential function. So the graph of exponential function looks like this. Okay, it looks like this. This is exponential function. So basically, if you go from left to right, understand, because like graphically also there are some students who get super duper confused that, ma'am, graphically we don't understand that what is increasing, what is decreasing, right? So understand, the moment you go left to right, your graph is going up, your graph is increasing, right? Left to right, always check left to right, because if you go from right to left, then what is happening? The graph is going down, so it must be decreasing. No. Always think about left to right. Okay? Left to right, the graph is increasing. So this is an increasing function. Do not think about right to left. Okay? Alright. So left to right, so this is left, this is right. Just tell me, the value at L and the value at R, tell me, which value is bigger? This value is bigger, right? Okay, so that means the moment you go left to right, the values are getting bigger. So that's why we call it as an increasing function. Okay, although we will get into the definition of increasing function, I am just giving you a rough idea right now. Then we will get into the proper definition. Okay, now tan x, again, okay, tan x. So tan x is also an increasing function. So if you remember the graph of tan x, it looks like this. The graph of tan x in minus pi by 2 to pi by 2 looks like this. So again, just understand, left to right if you go, the graph is going up. That's why it is increasing, right? Now 2x plus 3, line 2x plus 3. So if I put 0, I'm going to get 3. If I put 1, I'm going to get 5. So this is the graph. Just understand now. Again, left to right if you go, the graph is going like this. That means it is also increasing function. Okay. So these are increasing function. Now what are decreasing function? Let us understand. Yes, we are going to do questions also. We are going to understand concept also. And please let me spend some time in concepts, right? Because I know we will have more practice sessions, but we are going to have only concept session once. Okay, more practice session I'll bring, but only once we will understand the concept. Okay, so please give the time give the enough time to understand the concept, and then keep on tuck solving the problems. Okay, all right. Now e raised to power minus x. So the graph of e raised to power minus x looks like this. Now just tell me, from left to right, if you are going, the graph is decreasing. Okay, then we have cot inverse x, that is also decreasing, minus x cube. So minus x cube, the graph of minus x cube looks like this. So just tell me, the moment I go from left to right, so just understand this is left and this is right. So just tell me that left value is bigger, right value is smaller. Always it will happen. The left value will be bigger, right value is smaller. That means it is a decreasing function. Okay, all right. So now just tell me one thing. If I give you any graph, will you be able to tell me whether that graph is, ma'am, increasing or decreasing? Is that clear for you? Okay, monotonicity. All right. Okay. Now we understood what is monotonic. So all these functions are what? Monotonic function, because they are either increasing or decreasing. So what do I call? Monotonic function. Okay, all right. Either increasing, this is also monotonic, this is also monotonic. Okay, monotonic has two categories, increasing, decreasing. But you must be wondering that, ma'am, what is non-monotonic? What does non-monotonic function look like? So non-monotonic function means they have a combination of increasing and decreasing in the same graph. The moment you notice that combination of increasing and decreasing are in same graph, you will understand that, okay, this is a non-monotonic function. For example, sin x. Sin x graph, just tell me, looks like this. Now understand what is happening. So if I start from here, can you see from left to right the graph is going increasing. But the moment I reach here, the graph starts decreasing. Okay. So the graph is decreasing here. The graph is increasing here. And the graph is again starting to increase here. Right? So increasing, decreasing, increasing. What does that mean? Sin x is a non-monotonic function. Non-monotonic function. Okay. All right. Yes. Then we have mod x. So the graph of mod x looks like this. So again, just tell me, decreasing, decreasing, increasing. What does that mean? Non-monotonic. Correct? Yes? Okay. All right. Now let us just get into the definition part, the mathematical part. So first of all, one by one, we will talk about monotonicity at a point. Remember, we did the same thing in continuity and the differentiability. Continuity at a point. So in the beginning, we studied continuity at a point, and then we studied continuity at an interval. Same we are going to apply over here. So first, continuity at a single point we will study. Okay? Alright, not the whole graph. Just a single point. Okay? Thank you Darshan, thank you Vaishnavi, thank you Gavaskar, thank you so much. Okay. Alright. Now monotonicity at a point. So monotonicity, again there are two types of monotonicity, increasing and decreasing. Let us start with increasing. So a function is said to be strictly increasing at a point x equals to a if this condition holds true. Now what is this condition, ma'am? Because this condition is scaring us. I am scared of this inequality. Do not get scared. It is very easy. Okay, you will be like, I will tell you with the help of graph and you will be like, acha, like that. Okay. Hai. So suppose you have a graph. Okay. And this type of graph and you have a point x equals to a. So you are looking at this point x equals to a. This is the point. Now we need to know whether my function is increasing at this point x equals to a or not. Basically, it is monotonous at this point or not. So understand, for strictly increasing, we will talk about the neighborhood. Okay. So understand, there is a student. Okay. So there is a student who is sitting. Suppose you are sitting and giving your exam. So you get panic because somebody else, which is sitting just right in front of you, he is asking for supplementary copy one by one. Ma'am, copy. Have you ever witnessed this, that you are like writing something and you are not able to recall the answers, especially in social, English and chemistry paper, the theoretical paper, and somebody asks, ma'am, copy. Ma'am, copy. Ma'am, copy. Huh? Till you'll panic, right? So what is happening? You are actually looking for the neighborhood. The person who is sitting extremely left of you and the person who is sitting extremely right of you. Okay. Same thing. Monotonicity at x equals to a is defined by the values which are having in the neighborhood. Okay. So x equals to a. Now you have to take a point which is just right to it and a point which is just left to it. Okay. So suppose x equals to a is a value which is f of a. This is f of a. Correct? F of a plus h is having a value f of a plus h. And f of a minus h is having a value f of a minus h. So if a function is strictly increasing at x equals to a, the condition is that f of a should be sandwiched between a value greater and a value lower. So a plus h should have higher value. A plus h should have higher value. So this should be bigger. Then f of a and then f of a plus h. Okay. Alright. So f of a basically value should be less than f of a plus h. Okay. But should be greater than f of a minus h. If this is the condition, then only we can say that the function is said to be strictly increasing at x equals to a. Okay. This is the reality at a point. Now same thing we can apply in strictly decreasing. Okay. Strictly decreasing. Same thing. Okay. But yeah, somewhat similar but not exactly same. Now there are multiple cases. Okay. So this function, you can clearly see that this function is continuous function, right? So in continuous function also this definition is applicable. And yeah. So you can see, I will remove, yeah. So can you see f of a, this is f of a plus h, which is a value greater, and f of a minus h is a value smaller. Now one more thing, just tell me about it. Is it strictly increasing at x equals to a? You guys gonna tell me. Is it strictly increasing at x equals to a? So you just need to check, ma'am, f of a, so this is your f of a. This is your f of a plus h. This is your f of a minus h. So f of a is less than f of a plus h and f of a is greater than, right? This is f of a. This is f of a plus h and this is f of a minus h. So what do you think? Is it strictly increasing at x equals to a? Definitely it is strictly increasing at x equals to a. This is also strictly increasing at x equals to a. Now what about this? If you have understood this statement nicely, then you will be able to tell me that yes ma'am, this is strictly increasing or this is strictly not increasing. Yes or no? Is this strictly increasing? Because this is an discontinuous function. So it implies that it is applicable for discontinuous function. This definition, by the way, is applicable for discontinuous function as well. Beautiful thing happening over here. Okay. So let us understand. So ma'am, this is the value f of a, right? This is f of a. This is a. This is a plus h, a minus h. So this is f of a. F of a plus h. This is f of A plus H. This is f of A minus H. So obviously, can you see f of A is sandwiched between A plus H and A minus H, and f of A plus H is greater. So yes, this is definitely strictly increasing. है ना? So clearly from here, can I write that function need not to be continuous or differentiable. See, this is non-differentiable, but still it is having monotone. This is strictly increasing. This is discontinuous, but still this is strictly increasing, right? So even if the function is discontinuous at that point, then also we can say. Chalo. Now same I will be telling you for the strictly decreasing function. So strictly decreasing, it is very obvious that this time what will happen is f of A plus H will be lesser. This value is smaller. Okay, unlike the previous one, f of A plus H is smaller. So the inequality changes. F of A plus H is smaller. F of A is in the middle. F of A minus H. So f of A minus H will be greater like this. So this is the inequality. Again, same thing. F of A plus H has become smaller this time. This is this sandwich theorem? No. Sandwich theorem is very different. I am just using the word sandwiched in general. Okay, not the technical term. Sandwich, that means f of A should be in the middle. It should be a middle number. Okay, all right. This is not a sandwich theorem, by the way. Okay, all right. Again, same thing. F of A is in between. So basically, in between, if I am saying the number is in between. So f of A is in between. Okay. And then f of A plus H is a smaller value, f of A minus H is a bigger value. That's why again strictly decreasing. What about this? Yes. Now, tell me, f of A is lying in the between. So this is between. F of A minus H is greater. This value is greater and this value is smaller. So that's why this is strictly decreasing. Okay. All right. Yes. Clear? So I guess the graphical approach is clear. The basic definition is clear. Okay. Now let's come to the point, because so many of you are already writing about the derivative. That ma'am, differentiation should be positive. Hai na? Okay. So this will actually help you. This is not the definition. Understand. This is the working rule. Like how to solve the problems. This is not a definition. Okay. So this is a tool basically to solve the problem. So this is a problem solving thing. Problem solving tool. You can call it as a problem solving tool. Okay. All right. So whenever you find that the derivative of that function at x equals to a is positive, that means the function is increasing at that point. Here we are talking about that point. We're not talking about the interval, at a specific point. So if f dash x is greater than 0 at x equals to a, that means f dash a is positive, then it is said to be increasing. If f dash a is less than 0, then it is said to be decreasing at x equals to a. Okay. All right. Clear? Chalo. Now let's have an example, then understand. Check the monotonicity of a function at x equals to -1. Obviously, we need to differentiate it. Find f dash x. Put x equals to -1 in that. Okay. And then if it is positive, then it is increasing, strictly increasing. If it is negative, then it is strictly decreasing. Okay. Let's do this. So clearly, and also we can plot the graph as well. So first of all, let's plot the graph. Can we plot this graph over here? So the graph may x, this is x minus 3 and x plus 1. Correct? So -1 will be the root and 3 will be the root. -1 and 3 will be the root. Okay? So that's how this graph will be. Okay? -1 and 3. -1 and 3. -1 and 3. Upward facing parabola, and they are talking about at x equals to -1. Gauri, you are saying strictly decreasing function. No, this is not the correct way. Correct it. This is strictly decreasing at x equals to 1. So understand what is happening. -1, if we go just back, just left of the -1, a value is greater, and just right of the -1, value is smaller. So basically this is f of -1 is greater than f of -1 plus h and f of -1 plus -h. Okay. Okay. So that's why this is a strictly decreasing function at x equals to -1. By graphical approach we have seen. Now there is also another way of looking at it. Another way is finding f dash x. Finding f dash x. So finding f dash x will be what? 2x minus 2. F dash x will be this 2x minus 2. And now if you put x equals to -1 here, what will you get? The moment you put -1, you are going to get -2 minus 2. So this is going to become -4 less than 0. So f dash a less than 0 means strictly decreasing at x equals to a. So this is again strictly decreasing at x equals to -1. Yes, Gauri, we are going to, I'm coming on this. Hai na? First of all, let's tackle these 2 points one by one. Hai na? Yes, I'll take this case also. Chalo. Now what happens is, because we are continuously talking about, in the definition also we are continuously talking about ki go left hand side, a little left and a little right, check the values and check whether f of a is greater or less than these two, the neighborhood values. Accordingly apply the definition and talk about increasing and decreasing. That's what we are doing. But there is one-sided monotonicity as well. Remember, we were discussing one-sided continuity, one-sided differentiability, right? So one-sided monotonicity, what happens? So when you are not having, basically, you are not having any graph before A. If you are not having any graph before A, that means it is not in the domain, right? It is not given. Then you have to work with the help of the right-hand side only. So just tell me, this is A plus h. So just tell me, f of A is less than f of A plus h. So at x equals to A, what will you say? This is again strictly increasing. Okay? This is strictly increasing at x equals to A. Right? So f of A is less than f of A plus h. So this is increasing. And if there is no graph available towards the right of it, so tell me whether it is increasing or decreasing. Tell me whether it is increasing or decreasing. So clearly f of A is less than, okay, hold on. F of A is actually less than f of A minus h, right? F of A is, so this is, what is it going to be? So this is a decreasing function. This is a decreasing function. Okay. This is a decreasing function, है ना? Because the value is gradually decreasing. Chalo. Now I have one small exercise for you. Okay. So you've got how many points? One by one you are going to tell me, so that I just want to check whether you have understood till now or not. Okay. One by one to clear all the concept. So -6, 5, 13, 18, 24. 1, 2, 3, 4, 5. Okay. 5 points I am giving you, and just write down the answer. And please do not write random increasing, decreasing. I won't be able to understand. Just write at x equals to -6 increasing or decreasing, whatever you feel like. Okay. So let me just highlight the point. So this is basically this point. Hold on. hold on, let me just make the points clear थोड़ा सा. This point, क्या हो गया इसको? This point is -5 and this point I'm not able to like mark it, but this point is this point. अरे क्यों नहीं लिख पा रही हूँ यार? हाँ, this point. चलो ठीक है, -6. This is -6 basically. पता नहीं क्या हो गया. ठीक है, this is -6, then 5. This is your 5. This point is 5. Okay. So this point is 5. This is your hollow circle. This is your solid circle. Then this is your solid circle. And this is your hollow circle. This is your 13. Then this point, hollow circle again. So it is 18. Correct? Then 24. So this is hollow, this is solid. 24. Okay. ठीक है? Just tell me one by one. So -6 पे let us see. So again -6 पे we will have to like talk about. So this is again solid, है ना? Solid. Filled is there. So -6 पे what is happening? -6 पे we have a greater value. And the moment I just go beyond like -6 पे it is definitely decreasing. Anybody else? Yes. So many of you are saying decreasing. So -6 पे it is definitely decreasing. Okay. All right. So -6 पे decreasing. Then 5 पे. 5 पे. What are you saying about 5? X equals to 5 पे. है ना? So just tell me that 5 पे value is this. Correct? Below 5 the value is less. And after 5 the value is greater. So this value is increasing. Okay. Value is increasing. Okay. 13. Tell me at 13 what is happening. So 13 पे, just tell me. 13 पे the value. So 13 पे this is the value. And before 13 the value is greater. After 13 the value is greater. Oops. Not gonna happen. No, neither increasing nor decreasing at x equals to 13. Not allowed. Okay. Because 13, before 13 the value is greater. After 13 also the value is greater. No. It is not gonna work. Yes, absolutely, Gauri. है ना? Then we are having at 18. Okay, so this is your solid circle. Hold on. This is solid. Okay. So the value at 18 is this. The moment I go just right of it, the value is less. The moment I go the just left of it, the value is again left. So again, neither increasing nor decreasing. Okay. Yes, 18 पे neither increasing nor decreasing, and 24 last. 24 पे. Okay. So if I go towards the right, the value is less. If I go towards the left, the value is greater. So basically this thing is happening. Tuck. So this is decreasing. Check. All done, है ना? But you got incorrect in one point, beta, real English. X is equals to 18 is not decreasing, right? ठीक है? चलो, ठीक है. So these are the points. Decreasing, increasing, neither decreasing nor decreasing, neither increasing nor decreasing, then finally decreasing. ठीक है? Okay. It's fine if you watch from here, if you know the basics. It's fine. Till now we have not done the questions. Okay. चलो. अभी like there are multiple ways to go about it, है ना? So one student, Gauri asked that, ma'am, what will happen if f dash a becomes 0? Because till now I was telling you na, that to check increasing or to check decreasing, f dash a, calculate f dash a, and if it is positive, then increasing. If it is negative, then it is decreasing, right? But what happens if your f dash a becomes 0? Okay, if your f dash a becomes 0, then just observe the neighborhood sign. Yes, then you have to observe neighborhood sign, right of a and left of a. Okay, right of a and left of a. If both are positive, then we will say increasing. Okay, if you are getting stuck that f dash a ma'am is becoming 0, you said f dash a greater than 0, so it means it is like increasing, monotonically increasing. If it is negative, it is decreasing. But what ma'am, if it becomes 0, f dash a becomes 0, then again you have to check. You can't say neither increasing nor decreasing. You can't say non-monotonic. You have to check. If both left and right of x equals to a are positive, then the function is decreasing. Okay. And obviously, if both left and right are negative, then the function will be decreasing. That I'm gonna write. Okay. Okay. All right. So fx equals to x cube. Understand this. So at x equals to 0, we need to check whether it is monotonic or not. Although we can draw the graph, right? But what if you sometimes you don't, you're not able to draw the graph? Then what will you do? So ma'am, f dash x equals to 3x square. So if at x equals to, so f dash 0 is becoming 0. Oops, 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 oops. Okay, so what we need to do is we need to go a little bit greater than 0 and a little bit less than 0. That means f of 0 plus h and f of 0 minus h. So 0 plus h, so 3h square, this is going to be positive. 3 times minus h square, again positive. So if left and right of 0 are coming positive, that means the function is increasing function. Okay. All right. Clear? So this is what it is going to happen, right? So at x equals to 0, the value is f dash x is f dash 0 is becoming 0. But the left and right neighborhood becomes positive. That's why it is becoming what? Increasing at x. So what we will say? Increasing at x equals to 0. Final conclusion, increasing at x equals to 0. Okay? Okay. This is the graph of fx equals to x cube. All right, clear? And now again, I have already told you that the moment you get f dash a is equals to 0 and the neighborhood are negative, that means the function is decreasing at x equals to a. Suppose f of x equals to minus x cube. So obviously f dash x will be minus 3x square. So f dash 0 will be 0. So now if you check the neighborhood, you put a value which is slightly greater than 0. So it is going to become negative. And you put the value which is slightly less than 0. Again, you will get a negative value. That means neighborhood of 0, what are you getting? Negative, negative. Both are negative, the function is decreasing. So this fx is equals to minus x cube graph will look like this. Okay. Alright, so at x equals to 0, only I am talking about x equals to 0. So this is strictly, no, I will not say strictly decreasing, just generally decreasing. Okay. Decreasing at x equals to 0. Okay. Alright, now, what happens if you find that f dash a is equal to 0, okay? And if you try to find out the neighborhood, the sign you are getting are opposite sign, okay? That means, for example, fx equals to x square, right? Somebody is asking you to check at x equals to 0. So you'll be like, okay, f dash x equals to 2x. So f dash 0 will be again 0. So again, ma'am told us ki acha, you put a value which is slightly greater than 0 and slightly less than 0. So if you put slightly greater than 0 value, just suppose 0.001, you will get a positive, right? So right of 0 is a positive. And left of 0, if you put, you will get a negative. That means you are going to get the opposite sign. In that case, the function is neither increasing nor decreasing, okay? Neither increasing nor decreasing at that point, okay? So that means non-monotonic at x equals to 0. Yes? Okay. All the conditions we have discussed. And obviously the graph of x square looks like this. Just tell me. What is happening? 0 per value is less. And right of 0 the value is greater. Left of 0 the value is greater. That's why it is non-monotonic. Like that also we have to. Okay. All right. Clear? Hmm. Again, y is equals to sin x. We need to check at x equals to pi by 2. Obviously, we need to differentiate it and put x equals to pi by 2. Derivative of sin x will be cos x. Now, if you put, what will you get? So, f dash x, f dash pi by 2, tell me, is 0. Okay. So, if you're getting f dash pi by 2 is coming out as 0, that means we need to check the neighborhood signs now. Okay, the neighborhood signs, if I check of this, so if I put a value which is greater than pi by 2, so if I cross pi by 2, second quadrant mein cos is negative. So if I put a value which is higher than pi by 2, second quadrant mein cos will become a negative. And if I put a value which is less than pi by 2, first quadrant mein value will be positive. Again, that means this sin x is a non-monotonic function then, and we know that also at a point pi by 2, by the way. So can you see pi by 2 pe the value is bigger and the neighborhood values are smaller. So this is not fitting in the definition. Okay, so that's why it is a non-monotonic. No non-monotonic at x equals to pi by 2, my dear students. Okay. All right. Chalo. Now let us do some problems. Are we ready for some problems? Tell me. Are we ready? Problems ready? Check monotonicity of the function at these 2 points, right? Fx equals to x minus. Okay. Chalo, theek hai. So what we will do is, we will first of all calculate f dash x at x equals to 1. F dash x at x equals to 1, right? So f dash x will be what? Tell me. 3x minus 1 whole square. So f dash 1 will be what? 3, 1 minus 1 whole square. So it is coming 0. If it is coming 0, then tell me what to do. So ma'am, you need to check the neighborhood of f dash x. Okay. So you put a value which is slightly greater than 1. So f dash 1 plus and f dash 1 minus you have to do. F dash, a number slightly greater than 1, if you put, again you are going to get a positive. And f dash, a number slightly less than, but there is a square. This quantity can never be negative, so this is again positive. If both sides are positive, that means the function is monotonically increasing. No, you are wrong. Absolutely wrong. The function is monotonically increasing at x equal to 1, my dear students. Right? Monotonically increasing at x equals to 1. Understood? Got it? है ना? तो monotonically increasing at x equals to 1. All right. Now again this thing. Again f dash x, tell me. So this is going to be log of derivative of log x. Tell me. 1 upon 5x into 5. Correct? So this is 1 by x. So f dash 1 by 5. Now you put x equals to 1 by 5. So 1 upon 1 by 5. So this is 5. Now if f dash a is coming out as positive, now it is very easy directly. Because it was coming 0, that's why we are doing this whole thing. Remember? But if f dash a is coming positive, very first definition we have to, then to, okay ma'am, it is monotonically increasing. Okay. Now we know. ठीक है? थोड़ा you can show off. ठीक है? हाँ. So this is again monotonically increasing because so you don't have to go with neighborhood sign. ठीक है? All right. Next question. So understand. Now check the monotonicity at x equals to E. So first of all, what we need to do is, first of all, calculate f dash x. So this is going to be minus 1 upon x. Derivative of this will be 1 upon 1 plus x square. Now calculate f dash E. Minus 1 by E plus 1 upon 1 plus E square. Or I can do this. Minus 1 by E. Okay. Now just tell me one thing, that which value, okay, let's take LCM. E 1 plus E square. And this is E minus 1 plus E square. Now just tell me, between E and 1 plus E square, which value is bigger? Obviously 1 plus E square is bigger and E is smaller. So that's why numerator is less than 0. What about denominator? Denominator clearly is positive. E 1 plus E square can never be negative. So overall the expression is negative. So f dash E, if it is coming less than 0, what does that mean? That f is decreasing at x equals to E, by the way, at x equals to E. Okay. Thursdays are for mathematics, no? Dark night. That's why Shreyas sir is not taking the class today. Because I am taking, hai na? We both cannot take together. Can you attend 2 classes parallelly? All right. Now check the monotonicity at x equals to pi by 2. Chalo, let's see how many of you are able to get this question right. Again, f dash x is equals to 3 cos x minus 4 to the 8 sin x cos x. Okay. Now put f dash pi by 2. Tell me. So ma'am, 3 cos pi by 2. This is 0 anyway. Minus 8 sin pi by 2. Cos pi by 2. Oh, so this is coming out as 0. The moment you see that f dash x is coming out as 0, what does that mean? That means you have to check the neighborhood sign. Okay. Let's do that. So f dash x, so what I will be doing is cos x, I will be taking common, then this is 3 minus 8 sin x. Okay, so if you put a value which is slightly, so this is pi by 2. Pi by 2 pe you are getting 0. A value which is slightly less than pi by 2. That means you are in first quadrant. In first quadrant, cos is positive. So this is positive. What about this? 3 minus 8 sin x. 3 minus 8 sin x. So obviously sin x is positive. Okay, so this is going to be like pi by 2 pe, this value is 1. So 3 minus 8 into 1. So obviously this value will be negative. So that's why this is negative thing over here. And towards the right, if you go after pi by 2, again, this value will be negative. Why? Because sin x is still positive. In second quadrant, sin x is positive. So 3 minus 8 into like 8 into something. So this is a negative value and this is a second quadrant, cos is negative, so overall positive. Okay, so what is happening? Opposite signs, we are seeing the opposite signs. That means it is non-monotonous. It is non-monotonous. Okay, so that's why it is non-monotonic function. Clear? Perfect. Any doubts? Any confusion? ठीक है, चलो. One more question on your screen. Find the complete set of values of alpha for which the function is strictly increasing at x equals to 1. So understand, till now we are only talking about monotonicity at a point. Okay, we are still in that concept. We are not talking about monotonicity at an interval. That we will talk about, but right now again. But this question is a little bit different because now they are telling you that, oh, I am strictly increasing, but tell me the value of alpha. At what value of alpha this function is increasing? That's what it is like. Okay, so this can be done using a graphical approach. These type of question, so I would say do it with the help of graphical approach. Okay? So let's plot the graph. How many of you feel that I won't be able to plot the graph? Very easy graph, because can you see x minus 2 graph? Can't you plot? For x less than 1. Okay? So the moment you put x equals to 1, you are going to get what? If x equals to 1, you can't put, but still 1 pe 1 minus 2 is minus 1. So you are getting minus 1. So minus 1 is here. If you put x equals to 0, you are going to get minus 2. So 0 pe value is minus 2. Right? So this is how it is. Okay? So this is the graph. At x equals to 1, you have that alpha. That we will talk about later. But what about this? X square plus 1 for x greater than 1, right? So the moment you put 1, you are going to get 2. So this is 1, this is 2. This is 2. Right? So basically this is the graph of x square is equals to 1. So this is the graph of x square is equals to 1. But we will only talk about greater than 1. So this is the final graph. Okay? Now you have to place f of 1 should be what? So basically what they are asking is f of 1 is alpha. And that is what they are asking. What should be the value of f of 1 so that this graph become an increasing at x equals to 1. Okay, so we know that at x equals to 1, if a graph has to be increasing, f of 1 should be less than f of 1 plus h and should be greater than f of 1 minus h. This is how it is. Okay, alright. So f of 1 is obviously alpha. It should be less than f of 1 plus h. So value f of 1 plus h, that means you just go slightly greater than h. So this is the value which is 2. F of 1 plus h, obviously you are going to put it over here. 1 plus 1 limit you have to calculate basically. Limit, right hand limit. So this is actually right hand limit at x equals to 1. Right? F of 1 plus. So that is going to be 2. Correct? And what about this? 1 minus h. So 1 minus h pe left hand limit. So left hand limit is minus 1. So alpha belongs to minus 1, 2. Okay. So alpha belongs to, and there will be an equality sign over here, because tell me, if your f of 1 becomes this, if the graph becomes this, then tell me what will happen. If your alpha becomes 2, that means f of 1 becomes 2. Just tell me, will this be an increasing function? Yes. This will be definitely an increasing function, because f of 1 is 2 and f of 1 plus just something is actually slightly greater only. And f of 1 minus is slightly less only. So that's why close bracket we will select, close bracket. Gauri, D is not right. Why not D? C is the correct answer. Why? Just tell me. Do you have any problem if alpha becomes 2 or alpha becomes minus 1? Just tell me. If alpha becomes 2, let us make it 2. Let us make it as a solid circle. This is the value of f of 1. Just tell me, is it satisfying the condition of increasing function? Okay, ma'am, let's see. So, ma'am, f of 1 is 2. F of 1 plus something is greater and f of 1 minus something is lesser. So, now can you see this is satisfying? This is actually satisfying. Okay, that's why. And minus 1 also it will satisfy. That's why option B is absolutely right. Okay. Hi, Aerospire IITian. Thank you so much. Okay. All right. Till now it is clear. Now let us enter some confusion point. Some point of confusion is there. What is increasing, ma'am? What is strictly increasing? What is non-decreasing? Right? What is non-increasing? So let us understand more deeply. Let us understand the terminologies. Okay? So increasing functions pe let us understand. Increasing function pe. है ना, only increasing. Increasing functions are also called as non-decreasing function. Increasing functions are also called as non-decreasing function, which says that whenever you have dark night, what happened? I cannot understand. Previous question, you didn't get it? Acha, so many of you are saying. What you did not get? Tell me. ठीक है, one more time we'll do. Okay, so let us plot the graph again. Okay, just tell me. Let's plot the graph. Let's leave this part. Let's plot this and this graph for x less than 1 and greater than 1. Okay, for less than 1, if you put 1, you will get minus 1. 1 pe minus 1. So this is how it is. This is a hollow circle. Okay, this is your 1 and minus 1. Next, if you put 1 over here, so this is going to become 2. Correct? 1, ye 2. So this is how the graph of this will look like. Okay? Now just tell me that what is the condition of increasing function. The condition of increasing function, especially at x equals to 1, says that f of 1 should be less than f of 1 plus, and it should be greater than f of 1 minus. Okay, so f of 1 should be sandwiched between these two values. F of 1 clearly is alpha, so alpha should be sandwiched between a value which is slightly greater than 1, a value which is slightly less than 1. Okay, so 1 plus, that means f of 1 plus. How to get f of 1 plus? So this is 1. F of 1 plus, that means a value which is slightly greater than 1. So this is actually 2 and not even 2. This value is slightly greater than 2, right? So this is right. I am writing 2, but this is slightly greater than 2 only. And what about 1 minus? So if you go left, what is the value? Just tell me. So ma'am, this is, the value is actually minus 1. This value is minus 1, right? Minus 1 is the value. So this is minus 1. So alpha is lying between minus 1 to 2. So either this answer is correct or this is correct, right? But what I'm trying to say is B option. Let us check for alpha is equals to 2. What happens when alpha is 2? So if alpha becomes 2, then the graph of this function looks like this. That means the value of f of 1 will be 2. That means this will be a solid circle, right? Now just tell me, this whole graph is increasing or not? Alpha equals to 2 is satisfying the condition of increasing or not? So ma'am, it is very obvious graphically. So you have told us na ki how to check whether a graph is increasing or not. So ma'am, you are saying f of 1 is 2. Okay. Now what about f of 1 plus h? That means a value which is slightly greater than 1. So ma'am, it is coming this. So this and left of 1 will be this. Just tell me whether it is increasing or not. Yes, it is increasing. That means if alpha is 2, my function is increasing. That means alpha is equals to 2 will be my answer. 2 I will include in my answer, right? And minus 1, yes. So you guys are saying minus 1 also similarly. So if minus 1, if alpha is minus 1, that means this is now hollow circle. If alpha is minus 1, then what will happen? This is hollow circle and this is your full circle. Alpha is minus 1. That means your f of 1 is minus 1. Then just tell me again, same thing. F of 1 is this. And a value which is slightly less than is this. A value which is slightly greater is this. Just tell me, is it not an increasing function? Tick, tick, tick. Increasing. So that's why minus 1 will accept it. Definitely. Shubh, MOD is already completed. What happened to you? Differentiation, na? MOD is what? Methods of differentiation. Go and find. Okay? Now understand this definition nicely. A function f is said to be increasing or non-decreasing. Increasing and non-decreasing are exactly same. Okay? Increasing and non-decreasing are exactly same. So what they are saying is, the moment you pick any two values of that interval, right? Now understand, we are talking about monotonicity in an interval, right? Monotonicity in an interval. Okay? So suppose, yeah, so monotonicity in an interval matlab, suppose you are having a graph like this. Okay? So you take any 2 points on this graph. Okay? Suppose you are talking about the whole interval. You take any 2 points. Suppose you take this and this. So this is your x1, this is your x2. Now the left value, this which is a smaller value, x1 is less than x2. If x1 is less than x2, then the value at x1 should also be less. Value at x1 should also be less than x2, or it can be equal as well. Okay. So increasing or non-decreasing function in an interval, take any 2 values, and those 2 values may, if x1 is smaller, then the value at x1 should also be either smaller or equal. ठीक है? That we will do, Kritik, रुक जाओ, hold on. Gradually, धीरे धीरे, है ना? धीरे धीरे, final step we will achieve. You will understand, okay? Not added in playlist, is it? So you will find in the video, live videos, just go and watch, है ना? ठीक है? चलो. So now understand, equality will also work. Equality will also work. Okay, so we can call it increasing and non-decreasing. ठीक है? So let us just understand is it more. अभी तक देखो क्या बोल रहा है ना, कीर्तिक, I know that you are still looking for the one shot thing, like ma'am, tell me one statement and I'll be fine. Okay, to check whether the function is increasing or not. But we have not studied the whole concept till now. Okay, once we are, because see, monotonicity at a point we have studied, interval pe we will study, then we will combine these two and then ask me this question, then I will let you know. ठीक है? Okay, hold on, wait, patience. ठीक है? So now what is happening? Suppose this is a graph. Okay, so this graph is an increasing function. Why? Because if you take any 2 points on this graph, any 2 points, suppose x1, x2, if x1 is smaller than x2, then the value at x1 should also be smaller than x2, or equal is also fine. Okay, x2, x3, now can you see the values are equal? So if x2 is less than x3, then f of x2, value at x2 should be either less or equal from value at x3. So now they are equal, then also it's fine, right? So we will call it increasing. We will not call it strictly increasing. This is only increasing function. Okay, so this is a very important thing. So this might make you confused. What is increasing? Increasing is different from strictly increasing, right? Okay, all right. So yes, clearly f of x1 is less than f of x2. So this lesser condition is getting satisfied. And if I talk about x2, x3, so they are equal. Equal is also fine. Okay, x3, x4 again. x3 is less than x4 if I talk about value wise. Okay, so suppose this. Tell me whether it is an increasing function or not. So f y is equals to x cube, ma'am. This is actually a strictly increasing function. Strictly increasing function. Okay, increasing to hai. If a function is strictly increasing, that means it is definitely increasing. After that, it is like strictly increasing. Okay, all right. Jaise suppose some people are, you tell me, if I say that I am a vegetarian person, will you ask me, ma'am, do you eat meat? Obviously not. Okay, all right. So if I'm telling you this is strictly increasing, that means automatically it is increasing, right? Okay, yes, both. Now this log x. So clearly this is strictly increasing and increasing both. Okay, what about this? This is only increasing. This is only increasing. Why? Why this is increasing? And increasing functions are also called as non-decreasing functions. Increasing function are also called as non-decreasing functions. So what is happening over here? Basically, if you just tell me, this is suppose x1, this is your x2, this is your x3, this is your x4, then x5. Correct? Tell me. If I go from left to right, this value is x1. Okay, x1 is a smaller value. x2 pe, just tell me. Value at x1 is lesser than value at x2. That means function is increasing. But what is happening over here? Understand? Value at x2 and x3 are becoming equal. When equality is there at two different points, what does that mean? That function will be an increasing function. It is not at all a strictly increasing function. It is not at all a strictly increasing function. Have you understood my point? Have you understood my point? Any doubts? Any confusion in this? Tell me. Okay? Because again, I am going to tell you the definition of strictly increasing as well. ठीक है, तो strictly increasing में there should be no equality. Can you see? No equality. So definition of strictly increasing. है ना? So this is strictly increasing. There should not be any equality. F of x1 should be strictly lesser than f of x2. ठीक है? So we can call it as strictly increasing. And strictly is also known as monotonically increasing. Okay, strictly increasing or monotonically increasing are same thing. Okay, all right, yes. So suppose we have this. Now this graph is strictly increasing because no two values are same. There is no interval getting formed where the values are becoming equal. That's why we say it as strictly increasing or monotonically increasing. Right? Clearly, equality doesn't hold. And this is also a strictly increasing function. Strictly increasing function. Strictly increasing function. Strictly increasing function. Okay? Strictly increasing function. Now decreasing function. So you know decreasing ko we also call it as non-decreasing function. We will not call this function as strictly decreasing, or we will not call this function as monotonically decreasing. Here equality can happen. Two values can be equal. Okay. So here can we see that there are like multiple values, x1 and x2 values are equal. If the values are becoming equal, then what will happen is, if values are becoming equal, that means this is a decreasing function. Not decreasing function. Okay. So this is decreasing function. So this is strictly decreasing. This is strictly decreasing, but this is only decreasing. This is only decreasing. Only decreasing. Complex number, we have time in complex number. Okay, Dark Knight? Not now. Like in maybe last September end. Why it is decreasing? Because can you see two values are becoming same. Equality is happening over here. Okay, and now strictly decreasing. So strictly decreasing mein just understand there is no equality. Strictly or monotonic, no equality. Okay, all right. Equality is not there. So again, strictly decreasing, strictly decreasing, strictly decreasing. Okay, all right. Yes. Now, there was one student, right, who was saying Kirtik. Are you here, Kirtik? Are you here, Kirtik? Because he wanted to know it like one thing. Kirtik, are you here? Kirtik hi tha na naam. What was his name? So one student. Says yes. Kirtik, are you here? Is Kirtik here? If he is here, then this final thing now, finally we are concluding. We are concluding. Okay? We are finally concluding. See, understand why we are actually going into so much detail. Why we are like directly not coming to the point. Why I have wasted your almost 1.5 1 hour 15 minutes of your time, because this is the final thing, because this is only applicable for continuous and differentiable function. The final statement is for continuous and differentiable function, because if the function is discontinuous and non-differentiable, then you have to go back to the normal basic definition, the graphical definition. Are you getting my point? Otherwise, this method will get failed. Okay, so 90% you will find this method working for every other question in JEE main, but that 10% question, I don't want you to get stuck. So for that, if the function is becoming discontinuous, you have to mix both the methods. Okay, all right, yes, you are here. So now let us focus on this, because this will solve your 90% problem. Okay, okay, chalo. So if a function is continuous and differentiable in entire domain, then you don't have to worry about anything. Just differentiate it and check whether the function is positive at which interval. F dash x greater than 0 at what interval? Ma'am, this is increasing. F dash x less than 0 at what interval? Ma'am, this is decreasing. Basically, strictly increasing and strictly increasing if this is strictly greater than 0 and strictly less than 0. Now we are actually getting into it. So you can attend the lecture from here also. So suppose you have any function f of x that is continuous and differentiable. You differentiate, you find that function strictly greater than 0, that means that is strictly increasing. Strictly less than 0, strictly decreasing. Okay, all right, yes, clear. But now thoda sa there is a little bit, sometimes there is a little bit twist, because sometimes in the books you see the definition f dash x greater than or equals to 0. Now this equality, let us understand the equality, because this equality also has a twist. So now two cases are here. So if your f dash x is greater than 0, then you don't have to worry about anything. It's Kritik, not Kirtik. Okay, Kritik, like Ritik Roshan, Kritik. Okay, got it. If your f dash x is positive, then you don't have to worry. Ma'am, strictly increasing. But if your f dash x is greater than or equal to 0, then this equal to 0 you have to check. Equal to 0 you have to check. Now if this equal to equality occurs in an interval, so basically, can you see that f dash x equals to 0, that means horizontal tangent. That means horizontal tangent. So horizontal tangent, that means, so in this case, you just tell me, at this point, if you differentiate the function, you will get f dash x equals to 0. At this point also, at this point, actually, if you see fx equals to 5, if you differentiate this function, f dash x is equals to 0 for all the values of x belongs to R. What does that mean? That f dash x is becoming 0 in an interval. The moment you see f dash x becoming 0 in an interval, that means this is a increasing function. This is an increasing function, also called as non-decreasing function. Okay, so this is a eye opener for you guys. This is an eye opener for you guys. Okay, because a constant function is an increasing function. Did you know? How many of you know this? Tell me, honestly tell me. Constant function, students feel that okay, increasing function is like this, but constant is so definitely no, ma'am, no. Okay. All right. So how many of you know that constant function is an increasing function, but it is not at all a strictly increasing function. And here what is happening here? Can you see that f of x equals to x cube? Here f dash x is equals to 3x square, and f dash x becomes 0 at x equals to 0. That means equality is happening over here, but it is happening at exactly one point, discrete point or points. Basically, this is not forming an interval. This is like solo game, playing solo, not a group discussion. So that means this is again a strictly increasing, right? Okay. Okay, so strictly increasing, tell me when strictly increasing function can happen. When f dash x is greater than 0, to pakka, done, ma'am, strictly increasing. When f dash x is greater than or equal to 0, where equality occurs at discrete points, then also it becomes strictly increasing. But when the equality forms an interval, then it is not strictly increasing but an increasing function. Okay. Okay. All right. Yes. There is a Abhi, I have started blocking some people. So sorry, but I have to block him because I don't have time. हाँ, ठीक है. So here f dash x is becoming 0 at all values of x belongs to R. Here f dash x is becoming 0 at only x equals to 0. That's why. Okay. है ना? ठीक है. Now same thing for decreasing. है ना? F dash x less than or equals to 0. So if f dash x is equal to 0, forming an interval, if it is forming an interval, for example, constant function. So constant function is called as an increasing function, and it is also called as a decreasing function as well. This is a decreasing function because equal to 0 is forming an interval, and here can you see f dash x becoming 0 at x equals to 0. That's why it is a strictly decreasing function. Same definition, just with a less than 0. Okay. By mid-October, Janvi, by mid-October. Hopefully by September end or mid-October, we'll be able to. Okay. Chalo. Now let's do question time, because you guys are waiting for so long. I have taken a lot of time in explaining you increasing and decreasing. And now I guess all the questions will be cakewalk for you. Okay. I guess now let's start solving the questions one by one, tuck, increasing, decreasing. And let me know, just solve all the PYQs. You'll be like, okay, now so I'm like pro. Now I know everything in and out, everything, okay? So function fx is this, then we need to know increasing, decreasing, etc, etc, okay? So again, f dash x may, you have to just talk about when the f dash x is becoming positive, when the f dash x is becoming negative, okay? So f dash x, so product rule can I apply? X e raised to power something. So if x is constant, product rule, then the derivative of e raised to power x 1 minus x will be this, and derivative of this. So x minus x square. So 1 minus 2x plus this time e की power x 1 minus x is kept constant, derivative of x is 1. This is f dash x. Now what we can do is we can take common e की power x, 1 minus x can be taken common, right? And we are having x 1 minus 2x plus 1. Solve it. F of x is equals to e raised to power x minus x square as it is. And this is x minus 2x square plus 1. Can I take minus sign common? F dash x is minus e raised to power x minus x square. And this is going to become, tell me, 2x square minus x minus 1. Now this I can split. So this is going to be 2x minus 1. Sorry, plus 1, right? And x minus 1. Tell me, have I factorized it correctly? Because these days I am so like, my brain is not braining. So you guys tell me, factorization is correct or not? Huh? If you take minus sign common, you'll get this. Okay? 2x square minus 2x, perfect. Absolutely right. Cross check, done. Okay? So just tell me now what is happening. This thing is always positive. Exponential function are never negative. You know that. Negative sign is already there. Okay? And this 2x plus 1 and x minus 1. So wavy curve method we will plot. Okay? So minus half and 1. So this thing is always positive, right? And for safe side, because I know that sometimes you forget wavy curve method, just put the values. You put x equals to 2. You put x equals to 2, this is anyway positive. If you put x equals to 2 over here, positive, 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 but this negative sign will give you a negative. Then it will be a positive. If you put x equals to 0, tell me. So this is 1 and minus 1. So this is negative, negative, so overall positive. And if you put minus 1, you will get a, again, negative thing. Okay, so now just tell me. Here, my function will become an increasing function. Okay, minus half to 1. This will become again decreasing function, and this will become decreasing function. Okay, what are they asking? So the function is increasing on minus half to 1. Okay, absolutely right. And increasing in this interval, absolutely right. Option B, decreasing on R, this is wrong. Increasing on R, this is wrong. And decreasing on minus half to 1, so this is again wrong. Option A is absolutely right. Now tell me that, tell me, Krishna, I have already taken functions now. Why don't you go and watch that like lecture? Krishna, relations and functions already done nicely. Huh? A big class, like a 6-hour class has been taken. है ना? Roar series. ठीक है? I guess this is done. है ना? So we are done. This question. Now next question. Next question. Huh. Finally, this is having, yeah. One more question. JEE Main 2020. Chalo, who is here to solve the questions? Let's see, let's see. Fx is equals to x cos inverse minus sin mod x, where x belongs to this. Which of the following is true? So first of all, obviously we need to differentiate. Na? F dash x ka we need to check. If dash x is positive, if dash x is negative, we need to check, right? So for that, obviously before differentiating, na, let us first simplify it, because right now this is not in a differentiable form. So first of all, let's open the modulus, then apply some inverse trigonometric property, then simplify the question, simplify the function, then in the end we will differentiate. Okay. So yes, let me just write down. This is your function. Just tell me. So x belongs to minus pi by 2 to pi by 2. You know that mod x will be x when your x is greater than or equals to 0, minus x when your x is less than 0. Okay. All right. So just simply write x cos inverse minus sin x. X cos inverse minus sin x. So your function will become, when your x is 0 to pi by 2. When your x is 0 to pi by 2, understand what will happen. When your x is 0 to pi by 2, that means x is positive. This it will become minus sin x. So x cos inverse minus sin x. Can you see? And when your x is negative, that means minus pi by 2 to 0, then what will happen? Your mod x will become minus x. So minus sin minus x. Minus sin minus x will become what? Sin x. So x cos inverse sin x. Correct? Correct? Okay. Thank you so much, Shamila. Thank you. है ना? So this is fx. Correct? Now, you know that cos inverse sin x, cos inverse minus sin x. So do you know a property of cos inverse and sin inverse? The property says that sin inverse x plus cos inverse x is pi by 2. So it is very obvious that I'm going to convert this cos inverse sin x in terms of sin inverse sin x. Understand what I'm trying to say is, so when x, suppose I replace x by sin x. Huh. I am trying to replace x by sin x. Can I do that? Definitely. है ना? So both x are replaced by sin x. Now tell me, cos inverse sin x. So cos inverse sin x will be pi by 2 minus sin inverse sin x. Correct or not? And that is going to be pi by 2 minus x. Because sin inverse sin x becomes x in this particular interval. So this is actually becoming what? This is x pi by 2 minus x. Yes or no? Correct. And now what will I do is, again this time I will be applying a minus sign over it because I want cos inverse minus sin x value. So that is going to be x pi by 2 minus sin inverse minus sin x. This minus will come here, so this will become x pi by 2 plus sin inverse sin x. So this will become x pi by 2 plus x. Okay. So for first quadrant, my function is x pi by 2 plus x. For the second quadrant, yes, my function is x pi by 2 minus x. So this is my function. Understand? This is my function. And now, very, very easily, what I'm going to do is differentiate. So this is actually pi by 2x minus x square. Derivative of this will be what? Pi by 2 minus 2x. Derivative of this will be what? Pi by 2 plus 2x. Yes. Okay. Now that we have differentiated, what we were doing? Let us go back and have a look at the question. So what they are saying is, first of all, they are talking about multiple values. They are talking f dash 0 is minus pi by 2 or not. F is not differentiable at x equals to 0, decreasing or increasing. Now f dash, okay, hold on. They are saying, they are not talking about your function. They are not saying whether your function is differentiable or non-differentiable. They are saying that f dash x is decreasing. Okay. See, f is decreasing ke liye we need to find out f dash. To know whether my function is decreasing, what you check is f dash. To know where f dash is decreasing, you have to check f double dash. Right? So we need to again differentiate it second time. Right? So this is our f dash x. Now differentiate it second time. Okay? So f double dash. So first of all, f dash 0. If you put 0 over here, na, f dash 0. So this is also pi by 2. This is also pi by 2. F dash 0 to pi by 2. ठीक है. F dash 0 is pi by 2. ठीक है. And now double differentiation we have to do. Double differentiation. ठीक है. F double dash x. Tell me. So f double dash x will become minus 2 for this interval, right? Minus 2 and plus 2 for the first quadrant. Now tell me, f double dash x is negative. If f double dash x is negative, this implies f dash x is a decreasing function. If f double dash x is positive, f dash x is an increasing function. है ना? Right? Okay. So clearly, if f double dash is negative in this interval, that means in this interval my f dash is decreasing. So minus pi by 2 to 0 say my f dash is decreasing, and for positive this, in this interval my f dash is increasing. And now let us talk about the options, right? Let us talk about the options. Option A is absolutely right. Option B is wrong because we have just differentiated at x equals to 0. Option C says f dash is decreasing in minus pi by 2 to 0. That means option C is wrong. है ना? Oh, sorry, option C is right and option D is also right. Now, I guess the question was about, if it is a JEE main question, then the question is about which of the following is incorrect. Yeah? Which of the following is true? Okay, so all three options are correct. So this is a multi-select question, and multi-select question says A, C, D are correct. A, C, D are correct. A, C, D are correct. Okay. All right. Clear? ठीक है. B is wrong. ठीक है. Now let us move on to the next problem. And the next problem. ठीक है. The next problem says that the set of values of A and B for which the function is always increasing. Now this time they are saying that function is always increasing. What does that mean? That means f dash x should be greater than 0. or equal to also, equality also will work, है ना, always increasing, ठीक है. तो we will differentiate, आ जाओ, let's differentiate, है ना. F dash x equals to 2 sin x cos x plus sin 2x का derivative cos 2x into 2 plus a. This is your f dash x. Let us just do one thing. Let us just apply the formula. This is sin 2x plus 2 cos 2x plus a greater than or equal to 0. Right? So now a will be greater than or equals to minus sin 2x plus 2 cos 2x. Okay? Right? है ना? So a should, so understand, f dash x should always be greater than or equals to 0 for all values of x belongs to R. That means this inequality, this inequality should always be valid. A should always be greater than this value, right? Just tell me one thing, that what will be the minimum and maximum value of this overall right hand side? So overall right hand side, if I tell you a sin x plus b cos x की minimum value is minus square root a square plus b square. Maximum value is a square plus b square. Are you aware about it? This is a trigonometric thing. Okay. All right. So the minimum value of this will be what? Root 5 minus root 5. So minimum, है ना? So minimum, this right hand side, range of the right hand side. The right hand side value lying between minus root 5 to plus root 5. Right hand side lie between minus root 5 to plus root 5. Correct? Now my a should always be greater than or equal to all this value. Okay? Greater than. So a should always be greater. So worst case scenario. Just tell me. Can I keep my a as 0? Just tell me. Can I keep my a as 0? Will it be safer? Safe side, huh? Because always I don't want this condition to get like wrong. Just tell me, can I keep my a equal to 0? If a is 0, suppose if I keep my a as 0 and the right hand side becomes suppose 2, then just tell me, will the inequality be valid? No, not at all, right? Okay. So worst case scenario, maybe I have to like make sure that this a is always greater than the right hand side. Whatever is the value, this is a variable thing, right? So that means my a should be equals to root 5. Understand, any value of a which is less than root 5. Suppose a is 2. So ma'am, okay, a is 2, so I will keep a 2 and suppose the right hand side is root 5. Then this inequality is not happening. This is not getting true. This is not getting greater than or equals to 0. Done. Go home. Not increasing. What will you do? Are you getting my point? Okay. So you have to pick the safe value. So a can be equal to root 5 because if you pick root 5, this cannot be greater than root 5. Now maximum, it is having so much thing that okay, you want to go bigger. So go bigger. Become as much greater as possible. So it is maximum can be like root 5. It cannot go beyond root 5 now. So I will keep my a in such a way that my a is safe side, like always greater than this value. Okay. So a can be root 5 and a can always be greater than root 5. If I put like 6, so 6 is always greater than this, na? Okay. Ha. Nahi, okay. See, anonymous, you are saying, no, I am not saying x value. They are talking about set of values of a. If a, so we are thinking about what can be a. X to can be anything, na? X ko we are not saying. Okay, just forget about this. This right hand side Minimum value is root minus root 5, maximum is plus root 5. Understand? Now, what should I fix my value of A so that it is always greater than the right hand side? It should beat my right hand side. Okay, it should beat my right side, beat the hell out of it. So my A should, now I am just asking you, can my A be 0? If you keep A 0, then what will happen? This is your LHS. If LHS is 0, then if your RHS become root 5, then it will be a problem. Then it will be a problem because 0 is not greater than root 5. My inequality will not get satisfied. So I have to increase my A value because I have to be prepared for the worst case scenario, because I want this inequality to become true at all possible values of x. So that's why safe side I will pick A is root 5. Now you want to go root 5, go root 5. I am still like greater than or equal to. Yes, anonymous is absolutely right. That's what I'm trying to tell you. That because some people ask, ma'am, why you are not keeping 0, because it is lying in this range, 0 can satisfy. No, we have to be prepared for the worst case scenario, and worst case scenario in this case is if this becomes root 5 now, then my A will be like A has to hide his face. Where should I go? And that's why I'm keeping my A in such a way like that. So understand, this is you and your friend. This is you and your friend. Okay? Now your friend has a capacity of scoring root 5 marks. So safe side, you want to be safe, obviously you want to compete with your friend, you want to score more than friend. So safe side, you will be like, okay, minimum to I have to score root 5. After that, I can score as much greater than root 5 it is possible. Minimum, bare minimum to I have to get, because my friend's potential is like root 5. That's why it is root 5. Okay. All right. And what about B? So it is set of values of A and B. So B has no say. B has no say. You keep B whatever you want to, because B has no say, right? If dash x will be always be greater than 0 or equal to 0, B will not interfere in this. Because if dash x is not having any B, it is vanished, gone. Okay? Chalo. So finally, A belongs to root 5 to infinity. Okay? Now, composite function supremacy. Composite function supremacy. Okay? Composite function supremacy or composite function monotonicity. So, sometimes what they give you is function of x, they give you function fx, they give you gx. And they will give you what will happen with fog x. Is this monotonically increasing? Is this monotonically decreasing? Etc. Okay? So, let us understand the composite function. Suppose your f and g both are monotonically increasing functions, then your fog, gog, all are monotonically increasing functions. Understanding? If your f and g both are monotonically increasing, then your fog, gog, all are monotonically increasing. Understand what is happening. Okay. So, yes. So, if you understand that, how will I prove it? See, g of x. Just tell me, g of x is what? Given. It is given. This is monotonically increasing, right? So, if x1 is less than x2, just tell me if gx is monotonically increasing. This implies value at x1 will always be less than value at x2, right? Okay. Clear? Now, let me just do one thing. This g of x1, can I mark it as capital X1? And g of x2, can I mark it as capital X2? Can I do that? Yes. Okay. So, if x1 is less than x2, just tell me if for a function fx, because function fx is also monotonically increasing. Fx is also monotonically increasing. So, if x1 is less than x2, so for function f of x, because the definition says that this value is smaller, this is greater, so value at x1 should be less than value at x2. Now put x1 value. So this is g of x1 and this is g of x2. So just tell me. So this is fog x1 less than fog x2. Just tell me. So if this was given and you are implying that this is true, so if x1 is less than x2, your fog of x1 is less than fog of x2, this implies that this is an monotonically increasing function. Understanding why? Understanding the why behind why it is happening. Why it is happening. Are you getting my point? Very important, huh? Chalo. ठीक है. Ab now, if fx and gx are monotonically decreasing, what does that mean? है ना? So let us see again. So see, gx is a monotonically decreasing. That means if x1 is less than x2, this implies g of x1 should be greater than g of x2. That's what decreasing function, that's how decreasing function works, right? Value at x1 will be greater, no? If x1, see, if x1, this is x1, this is x2. So x1 value obviously should be greater, x2 should be lesser if it is a decreasing function. So g of x1 is greater than g of x2. Now let me mark it as x1 greater than x2. Okay? Now understand. fx is what again? Decreasing function. So if your x1 is greater than x2, है ना? That means this is your x1 and this is your x2. So value at x2 will be what? Understand? Value at x2, f of x2 will be greater than f of x1. Now put the values. Okay. So this is f of g of x2 and this is f of g of x1. So this is fog x1 less than fog x2. है ना? So we started from here. x1 less than x2 implies fog x1 less than x2. Okay, ma'am, if both are monotonically decreasing, that means fog x is actually monotonically increasing. Okay, all right. Yes, anonymous, monotonically increasing. All right. Gof x may be also monotonically increasing. Okay, this is also done. Now fof x, hold on. Fof x. So fof x actually, the fof x is handling this. So if two functions, if like internal, basically both, if both are decreasing, na see, decreasing, so monotonically increasing, decreasing, monotonically decreasing, decreasing, monotonically increasing, decreasing, monotonically increasing. हाँ, anonymous, absolutely, anonymous, ekdam on point. So anonymous actually pointed out, ma'am, if a function is monotonically increasing, then you just do not change the sign. x1 less than x2, g of x1 less than g of x2. But a function is monotonically decreasing, then you have to change the sign. If x1 is less than x2, then you have to reverse the sign. Okay? Okay? So this is how it is done. Okay? Now you tell me, if fx is monotonically increasing, gx is monotonically decreasing, then gof x, tell me about fog x. So first of all gx के लिए, so ma'am if x1 less than x2, so gx is monotonically decreasing, right? So that means ma'am g of x1 is greater than g of x2. Okay, and now just do not think about it much. Now you want f. F में there is no sign change. F of g of x1 greater than f of g of x2. So we started from here, less sign, and we are achieving a greater sign. That means what? Less and greater. Sign is changing. That means it is a monotonically decreasing. This is also monotonically decreasing. Now f of x. See, f of, so both are increasing, that's why monotonically decreasing. Gx, g of gx, both are monotonically decreasing, that's why monotonically increasing. See, very simple. When these two are from same thing, either increasing or decreasing, then your final result will be increasing. If these two are opposite, increasing, decreasing, then this will be having decreasing. Okay, chalo, let's see, है ना? Let's see. Although you don't have to like cram it completely, because we have the original method also that will help you with everything. Just like we are going to solve this question, f of x is equals to this, g of x is equals to this. Okay, so f of x, now f dash x, sorry, you are looking for what? Tell me. Okay, you are talking about fog x. So first of all, form f of g of x. Create f of g of x. है ना? Create f of g of x. Do not, if you do not know that method, na, that table, if you've forgotten, na, then also you will be like, ma'am, you done it. Just use the chain rule principle, you will be fine. Even if you don't know the method. Go with the basics. Can you not create f of g of x? Absolutely, right? So now f of g of x. So yes, f of x is your e ki power x minus x. Now replace x by g of x. So f of g of x, e ki power g of x minus g of x. E ki power g of x. E ki power g of x. E ki power, what is g of x? X square minus x square minus x. Perfect. This is your fog x. Now what will you do? Differentiate. So differentiation, f dash. Differentiation. This is your function now, right? This is actually hx. Now differentiate. Simple. H dash x, tell me. E raised to power x square minus x. Correct? After that, you are having minus x minus, सही किया ना? ठीक है. E की power x square minus x, then we have 2x minus 1 minus we are having 2x minus 1. Perfect. Yes, 2x minus 1 can be taken common, and inside that you will be left out with e ki power x square minus x minus 1. Now we need to check whether this thing is positive or negative. Okay? Alright, so what we will do is we will plot the root of both the factors. This is becoming 0 at x equals to half. So x equals to half we will plot in a number line. Okay. Then what about this? When will this become 0? Who is going to tell me? E ki power x square minus x is equals to 1. This will become 0 when this is like this. 1 can be replaced by e ki power 0. That means x square minus x becoming 0. That means x equals to 0, 1. So 0 and 1. Okay. Alright. Just tell me. If you put any number which is greater than 1, obviously this will become positive. Any number greater than 1. Okay, so this will become positive. Yes, this will always become positive. So greater than 1 pe, it is becoming positive. Half to 1. Half to 1. Now half to 1 pe, this will become negative. Half to 1 pe, this will become negative. Okay? Half to 1 pe, this is going to become negative. This is still positive. So overall it will become a negative thing. Now 0 to half. 0 to half pe again it is negative, and this is also negative. So overall positive, and less than 0 पे, this is negative but this is positive, so overall it is negative. Okay, so now function is increasing where? 0 to half पे increasing and 1 to infinity पे increasing, 0 to half, 1 to infinity. So this is going to give us option. Which option? Yes, option D as absolutely right. Perfect. Yes, clear. Perfect. Now this is how it is done. See the wavy curve method. Plus minus alternate. Clear? Chalo. Next question based on the table. Now you have the table. Now you can solve this all the questions clearly. Okay. So now they are saying that f of g of hx is an increasing function. They are claiming. Then which of the following is not possible thing? Okay. Which of the following is not possible? Okay. If f of g of h of x is an increasing function, then which of the following is not possible? So we have to go by the options. Okay, option A, option B, one by one we have to pick the options. If these three functions are increasing, then what will happen? If these three functions are decreasing and this is increasing, then what will happen, right? So we have to take multiple cases. Are we ready? So option A says if f, g and h are increasing, then we need to derive what will happen with the composite function f, g and h. So first f, g, h all are increasing. Okay, this is option A. Option A says f, g, h. What we need to make is f of g of h of x. So understand, x1 is less than x2. So now h of x1 will be less than f of h of x2. Correct? H of x1 is less than h of x2. Right? Because h is an increasing function, sign will not change. Now g. If I just take g on both the sides, again sign will not change. Why? Because again g is also an increasing function, and in the next step if I take f on both the sides, again sign will not change. Why? Because f is also an increasing function. Now this is f of g of h of x1 less than f of g of h of, this is sorry, x2. है ना? So what does that mean? If x1 is less than x2 and this f of g of h of x1 is less than, that means this is an increasing function. है ना? So if these three are increasing, my forgo function is an increasing. If these three are increasing, that means my forgo is an increasing. Option A is absolutely right. Okay. Now option B says F, G are decreasing but H is increasing. Okay. है ना? Option B. F, G are decreasing but H is increasing. So again, x1 less than x2. H is increasing. Take H both the sides. So no sign change. But now for G, sign change will happen. Sign change will happen. Right? So sign will change. And for F, again sign will change one more time. So if this is the sign, then go back to the same sign. So again, है ना? So this is now become f of g, forgo. Forgo x1 is less than forgo x2. So what happened? H may no change, but G and F may twice sign change. So come back to the same sign. What does that mean? That if x1 is less than x2, forgo x1 is less than forgo x2. Okay. So matlab option B is also right. Option B is also right. What about option C? Option C में what will happen if x1 is less than x2? ठीक है, option C directly I can do it now, है ना? Now h is decreasing. Take h both the sides, so sign will change. H में sign will change. Now take G, so again sign will change. GH sign change. And now F में again sign change. तो now this तो this हो गया greater. FGH. तो Pogo function में finally what will happen? Less than का greater हो गया. Less का greater, that means this implies that my Pogo is a decreasing function. That means which of the following is not possible? So C option is not possible. And F, G are increasing and H is decreasing. So one time sign will change and there will be no return. Sign will overall change. So option D means again my Pogo is decreasing function. Nice name, na? I will in future, if I ever want to have a pet, I will name that dog as what? Guess what? I have a name in my mind. Name of my pet dog will be Pogo. F of G of H of X. है ना? Pogo. So how will I like play with my dog? Pogo, come here. Pogo, no. Pogo, go there. Pogo, sleep. Like that. Yes. So not true, not possible. The C and D are not possible. So we will tick C and D. Okay. All right. Clear. Okay. Chalo. One question from JEE main April attempt. Are we ready for it? Nice name, na? Nice name, dog ka. How did you guys like it? Is it good? ठीक है, चलो. Now, good question, a very good question, I would say. So there is a function which is a twice differentiable function such that f double dash is greater than 0. Now, who will tell me if f double dash is greater than 0, then tell me ki, what will happen? Like, what is the interpretation of this? If f double dash is greater than 0, then definitely there will be an increasing function. But what exactly? Which function is an increasing function? Tell me. If f double dash x is greater than 0, that means my f dash x is increasing function. Obviously, in this interval, for all values of x belongs to 0 to 2. ठीक है? No. Concave upwards तो ठीक है. No, f dash x is an increasing function. Now, till now, we have not studied na concave up. तो ठीक है. है ना? F dash x is an increasing function. ठीक है? And phi x. Now, they are talking about phi x. What will happen with phi x? So, they are talking about phi x is increasing, phi x is decreasing, and so on, something like that. है ना? So, let's take two cases. Case number 1. So phi x is given phi dash x. Let me calculate phi dash x. ठीक है? So phi dash x is what? F dash x minus f dash 2 minus x. Right? If I differentiate this, f dash 2 minus x and derivative of 2 minus x is minus 1. So phi dash x is coming like this. है ना? F dash x minus f dash 2 minus x. Now this is phi dash x. Now case number 1. If my phi x is a is an increasing function. What will happen if my phi x is an increasing function? We need to check. And the phi x is increasing. That means phi dash x will be greater than 0. Correct? That means f dash x, this implies f dash x will be greater than f dash 2 minus x. And by the way, now we know that my f dash is an increasing function. So can I just do a reverse thing? If f dash x is greater than f dash 2 minus x, that means x should be greater than 2 minus x. That simply means that 2x is greater than 2 and x is greater than 1. Right? Okay. X is greater than 1. So phi, basically my phi x is an increasing function in this interval. Obviously my x is, so we are talking about x belongs to 0 to 2 only. Obviously x greater than 1, but we are still less than 2. So my phi x is increasing. I have assumed my phi x increasing and this is giving an interval. Yes, phi x is increasing, but in x greater than 1. So from 1 to 2, and my phi x is increasing. What does that mean in 1 to 2? So this is wrong because my phi x is increasing. In 1 to 2, this is also wrong. Increasing. Either this increasing in 1 to 2 or this is correct. Okay? Now, again, case 2. Case 2, let us assume that my phi x is decreasing. What does that mean? Phi dash x will be less than 0, right? That means f dash x will be less than f dash x minus, 2 minus x. 2 minus x. 2 minus x. ठीक है? F dash x. Now f dash तो is confirmed. F dash x is my definitely increasing function. So you just remove f dash x is less than 2 minus x. So 2x is less than 2 obviously. So inequality, so x is less than 1. Obviously the case here is x belongs to 0 to 2. So 0 to 2 may for less than 1, that means x belongs to 0 to 1. My phi x is coming out as decreasing. So now you just tell me 0 to 1 may it is decreasing. 0 to 1 may it is decreasing. And 1 to 2 may it is increasing. All right. Very good. Very nice. ठीक है? Yes. Decreasing in 0, 1 and increasing in 1, 2. JEE Main April attempt 2019 question. ठीक है? Now let us take a quick break and let me just come back and talk about maxima and minima. ठीक है? So I will be coming back. Let's meet at, so 9:20 हो रहा है ना? Let's meet at 9:35 है ना? Resume at 9:35. Okay, let's take a break है ना? One by one we will complete Trivikram because you guys are like every time. See, after this we have integration. After this we have permutation and combinations part 2 that will be done within this week. Then we have circles and after that we have complex numbers. After that we will do parabola, ellipse, hyperbola, and then parallelly we'll do vector 3D. Na? One by one we will do it. Hai na? One by one. It will take time. Na? Syllabus completion takes time. Okay? All right, all right. Thank you, thank you. So many Teachers' Day wishes today, huh? Yes, I will post the notes right after my class. Okay, Joseph. Hi, Tarun. Thank you, thank you. Janardhan. Hi, Nidhi. Thank you. Then we have Sabita, Anonymous. Thank you so much. है ना? Chalo, chalo. Maxima and minima. You guys were waiting for this for very long, huh? Maxima and minima. But let me tell you, the weight is worth it. हाँ, the weight is worth it. Okay. ठीक है. चलो. First of all, maxima and minima में first we will talk about local maxima, local minima. Okay. What is local minima? How does it look like? So if you first of all if you see the graph, you will understand what is happening. So in this graph, we can clearly see that this point is local maxima. So what happens when local maxima hits? So see, if you have a point x equals to c, right? This is your point C. Again, same thing. We did an increasing, decreasing, na same. So now f of c is slightly greater than f of c minus h and c plus h. This is the definition. That's it. Right? F of c should be greater than their both neighborhood. Left and right, both neighborhood. So this is what we call as local maxima, local minima. Have you seen that, like which movies, like the gangster movie in South mein, to there are so many gangster movies, right? And tell me one movie wherein like they have some goons and all, local goons, and then they have like bigger goons. Tell me one movie, huh? So local extrema or local maxima is like local, like gully goons. Like this is my area, है this colony is my area. So this is what we call local maxima, wherein we will not talk about like some other state. We will not talk about gully ka don, है ना? We will only talk about the neighborhood. It may be possible that if you look at the complete whole graph, there may be a value which is like way too above. No, but we are not looking. We are just talking about the neighborhood. If f of c is slightly greater than its neighborhood, we will call it as local maxima. Okay. So local maxima. So f of c should be greater than both left and right. So we will call it as f of c, we call it as local maxima, and x equals to c, we will call it point of local maxima. Point of local maxima. है ना? Point of local maxima. Are you understanding my point? है ना? So when they ask you, tell me the local maximum of this function, then you tell the value. But they will, if they ask you point of local maxima, so you won't tell the value. You will tell at what value of x you are getting that maximum. Are you getting my point? Yes. So this is what we call as local maxima. Now, local minima. Local minima. So you understand f of c is slightly lower than the left and right both neighborhood. So f of c should be lesser than both. So we will call f of c as local minima, and we will call x equals to c as point of local minima. Definition. This is pure definition. But ma'am, this is the understanding, okay? Exactly this thing we call local maxima, this thing we call, but how to solve problems, okay? That we will understand what is the tool, how to like figure out that where to get maxima, where to get minimum. But first of all, we will again understand one-sided extrema. Suppose we are not having anything which is after this. This is C, this is C minus H. There is no graph after C. So now we have to like manage with the left hand side. And now we can't say, like, please spell, first of all, take the right graph, then I will think. No, if it is not given, we have to manage. Okay, so f of C is slightly greater than C minus H. That means f of c is local maxima and c is the point of local maxima. And here in this case, again, this point is lower than its left neighborhood, right? So it's not even there. So we will call it as point of local minima, and this is your local minima. Okay. Now let's talk about anonymous one-sided limit. Will one-sided limit be used when you are confused? See, in questions they give you na x belongs to 0 to 2. Huh? They give you na? They give you the whole question and they only give you x belongs to 0 to 2. What does that mean? You have nothing towards the left of 0. You have nothing towards the left of 0 and you have nothing towards the right of 2. So that's why in that case you get confused. Ma'am, what about x equals to 0, like left, right? Then it will be very important. Okay. All right. Yes. So now global or absolute extrema. Global or absolute extrema means the overall dawn of the whole, like global dawn. It happens na, two like small people are fighting, but then in South Indian movies it happens. I have seen that. Then I am like Shiva, I am back. ऐसे करके आता है. Like it's like bigger, like the bigger one. Overall, है ना, which who can defeat everyone. So global means highest value overall in the complete graph. So we can clearly see this. This will be the global maxima, overall maximum value. But this is also, can you see, this is also a local maxima. है ना? So global maxima is overall maximum value. Local maxima is it should be greater than its neighborhood. Right now, this point is actually local maximum, but it is actually also global maximum as well. Right? Yes. Okay. And again, if I talk about this, this is again in this graph, this is global minimum and local minimum as well. Okay. All right. Yes. Now just tell me about the point P. What is happening P pe? One by one. So this P, ma'am, okay. P, P. So P pe value is less, after that value is greater. So P pe we have local minima. Q pe we have local maxima. This is again local minima and this is again local maxima. Correct? Now tell me, what is global maxima? So this point is global maxima also, or absolute maximum. You can call it as absolute maximum. And what about global minimum? So this is global minimum. Okay. All right. Clear? Yes. Guggen circles will be done by next Thursday. You know, by next Thursday. Before that, I have permutation and combination and integration aligned already. So I have a slot on next Thursday only. Okay. Okay. Before that, I am so sorry. So P is, say, local minima, Q is local maxima, and R is local minima and global minima both. And then S is local and global maxima. Clear? ठीक है? All right. Yes. Now we are having this. Okay, chalo. Let's see how many of you. Arey, Samhita. It will be done in October first week. है ना? October first week. Vectors and 3D geometry. Thank you, anime. No, today no mean value theorem will not be covered today, Sanjay. है ना? ठीक है. Just tell me about A is what? One by one. A is what? So A is local maxima. What about B? Can anybody tell me whether it is minima or maxima? At x equals to B. Very important, huh? This is something that most of the students might tell you the incorrect thing. हाँ, B पे बताओ. B पे local maxima you are saying. Okay. B पे there is local minima. Okay. All right. Local minima. Minima, not maxima. Why, ma'am? But why? It is looking like local minima, right? Local max. It is looking. Sorry. My bad. Sorry, this is also maxima. Huh? My bad. Okay. Huh. So it looks like it is a minima, but it is maxima. How come? Because you see, this value is greater than the neighborhood value. That's why it is local maxima. My bad, hai na? Okay, so this is local maxima. What about this? This is also local maxima. This is local minima. What about this? Local maxima. And tell me about this now. F. Hai na? So see, A is local maxima. B is also maxima. C is local maxima, but it is global maxima also. And D is, this is global minima also. D, right? D is the smallest value. And then E is local maxima. What about F? What about F? So F pe, the previous value is slightly lesser. So this is again local minima. Yes. So I guess if this is clear now, then definition at least is clear. Till now, if you are like done with this. Yes. Roles and Lagranges will be covered in a separate lecture, Sanjay. है ना? ठीक है? हाँ, ठीक है. Acha, normally we have seen till now, we have seen that there is one local maxima which coincides with global maxima. It happens, right? We have seen that local maxima coincide with global maxima, local minima coincide with global minima. But there are some exceptions as well. Yes. Okay. So can you see the global maximum value is actually this. Hold, the highest value is everywhere between B to C, right? Between B to C, highest value is this. But is there a local maxima? No. But why? Because it is not satisfying the definition. Definition of local maxima says that it should be, even if it is slightly greater, it is fine, but it should be greater than the neighborhood. So if we go here and if we talk about the left and right of it, it is not even smaller. And even if I talk about this, na B. So B pe the left side is value is smaller, but what about the right side? Right side value is not at all smaller. That's why there is no local maxima, but there is a global maxima. There can be exception, by the way. There can be an exception, hai na? But can be an interval. But understand, anonymous, at x equals to B also we are not getting local maxima, right? So what does that mean? That if I ask you the value of global maxima you have, but actually there is no local maxima, no local max. If I ask you that tell me the value of local maxima, you will say no value. No value of local maxima. Now there may be a possibility that global maximum is not even available, hai na? So suppose this is a function. Suppose this is a function, hai na? Just tell me what is the value of, so this point is, just tell me, this is A is again local max, this point B is local maxima, correct? What about this? This is nothing, because this is an open circle. So A pe there is nothing actually, hai na? A pe there is nothing. What about C pe there is local minima, hai na? But do you feel that there is a global maximum value? No, it is not defined, because the overall maximum value, if I try to go and find out, it is actually, it seems that it is coming at x equals to D, but x equals to D pe there is open circle, it is not even in domain. So global maximum we cannot say, like there is no defined particular value which I can tell. I know that maximum value is somewhere around here, but it is not clearly defined. So there is no global maximum, and similarly this case no global minimum. So it may be possible that we have local maximum, local minimum, but global maximum is not even defined, like we cannot tell, right? Okay, so there may be a possibility. Global minima, minima is defined, yes, sorry. Global minima is defined, na? Minimum value to we can find. This is overall minimum is this, but overall maximum is not this. Overall maximum is not this. Overall maximum is this, but this is not defined. Okay, all right, clear? Chalo. Now we have a question. Let's have a question and understand. For fx is equals to mod x, है ना? So mod x. So let's just plot this graph. What do you think? है ना? Plot this graph. Mod x का तो graph looks like this, and x belongs to 0 to 2. That means x belongs to minus 2. This is minus 2. So basically this is minus 2 to 2. And at x equals to 0, we are having a 1. So just tell me what is happening at x equals to 0. Is it local maxima? Is it global maxima? It is minima? Just tell me. So first of all, let's check for what is happening at x equals to 0. So f of 0 is obviously 1. But what about, so f of 0 is 1. So f of 0. Now f of 0 plus h is close to 0. है ना? So f of 0 is greater. F of 0 पे ये value है. This value is greater than its both the neighborhoods. So when a value becomes greater, it is becoming maximum, local maximum. Local maximum. It is not a minimum. My 0 value is becoming a little bit higher than the neighborhood. This is the value. This is not the value. That's why it is a local maximum clearly at x equals to 0. Okay. All right. Yeah, anonymous. See, you can do it without graph, but see, again the same thing. The whole chapter, let me tell you that when exactly you are going to get stuck, you find all the problems and the normal method of getting an increasing, decreasing function or getting in minima or maxima. If a function is differentiable and continuous, then you can do it without a graph. You have a set method, apply it. But when a function becomes non-differentiable, discontinuous, then the derivative test will fail, right? You can't find derivatives. See, at x equals to 0, can you find derivative? Not at all, right? Because there is a like breakage and everything. So what does that mean? That's why. So application of derivative chapter is fun and games until the function is non-differentiable. Okay. When the function becomes non-differentiable and discontinuous, then you are like, then you have to do another methods. Okay? Clear? Chalo. Let's do another question. Again. So same thing. Fx is given as this and they are talking about x equals to 1. Again, the same problem arrives. At x equals to 1, there is a breakage. Breakage means there may arrive a discontinuity. Now the methods, normal traditional method will go in vain. But you know what? We are actually starting with that pain point, and then what we are doing is the normal method everybody knows. Okay, double dash, first derivative test, that we will always study. But first of all, we are clearing the basics with the help of graphs. And then the tried and tested method will be applicable everywhere. 90% you will get that. Okay, that we will anyway do. But this is something which will make you solve those 10% problem which are having like something, this derivative test is not working. You will be like, that's why in comment section everybody say, ma'am, we are getting confused. We are not understanding, because students want, give me a question, I'll differentiate, I'll do the set method. But this chapter is like playing with you. It will not give you that method for every function. If the function is breaking, then you have to plot the graph and all. Chalo. So 2x minus 3, plotting of this is very easy, right? 2x minus 3, tell me. Chalo, इसमें draw करते हैं. 2x minus 3. So the moment you put x equals to 1, you are going to get minus 1. So 1 pe we are having minus 1. See, so 1 pe, so this is the graph 2x minus 3, right? So 1 pe, this is your 2, this is your 3 by 2, it is becoming 0. 3 पे it is becoming, so this is your straight line, 1, 2, 3, this is your straight line, correct? Okay. All right. है And now at between 0 to 1, we are having minus x cube plus some constant k. Can I write it this way? Now minus x cube graph. Just tell me minus x cube graph. How does this minus x cube graph look like? So minus x cube graph is this, right? Y is equals to x cube graph looks like this. Y is equals to minus x cube look like this. नहीं this, this. है ना? This. But we need to plot this graph. This is minus x cube. What we are looking for is minus x cube plus some constant is there. Okay, so this is minus x cube from 0 to 1. So we have removed everything. Now this graph minus x cube plus constant can be like this, plus we need to add some constant. So it can be like this also, right? It depends on what the constant part. It can be this also. It depends on the constant, right? It can be one of these, all these graphs, okay? And there will be a hollow circle everywhere. Now what do I want? I want that this graph will have a smallest value at x equals to 1, right? My graph should have the smallest value at x equals to 1. What does that mean? Just tell me. Okay, consider this branch. Consider this branch, okay? This branch. So suppose this branch, if this is the branch, then the overall, forget about this, this and this. Okay, so graph will be this and this blue colored. Okay, ma'am. Okay, got it. If this is the graph, then the smallest value, and this is the filled circle. So the smallest value is not this, but the smallest value will be not be this, but the smallest value will be here. So that means this graph is not at all good. Okay, it is not satisfying. It is not satisfying. Smallest value should be at x equals to 1. So this should be rejected. Right, now let's talk about this. If my graph is exactly this, that means my constant value is 0. This is pure minus x cube plus 0 graph. So if my graph is this, then what is the smallest value, ma'am? Smallest value is this only. That means if my graph is this, then smallest value is actually occurring at x equals to 1. And if my graph is this, then also it's fine, because if this is the graph, now see what is happening. What I'm trying to say is, if this is the graph, then it is a problem. But if except this graph, any graph which is above it, so all the graphs are satisfying, because then the smallest value will be here. Okay, all right. That means the constant part either can be 0, right? This graph is constant part can be 0, or the constant part can be 0 or can be greater than 0. So the constant part can be greater than or equal to 0. Definitely. Constant part can be greater than or equals to 0. So b cube minus b square plus b minus 1 upon b square plus 3b plus 2 should be greater than or equal to 0. And 0 is also possible, because absolutely if your graph is just minus x cube, if this quantity is 0, that means your graph is minus x cube, then also your smallest value is satisfying. Okay, so now just solve it. So this is b square plus 1, b minus 1, and this is b plus 1, b plus 2. Remember wavy curve method? In wavy curve method, this is always positive. So this has no use. Remember that ghost expression. Now b is equals to 1, minus 1 and minus 2. Plus, minus, plus, minus. Okay. So yes. So what is your answer? It should be positive. So 1 to infinity and minus 2 to minus 1. So minus 2 to minus 1, minus 2 to minus 1 union 1 to infinity will be your answer. Okay, 1 close. 1 close and -2 to -1 open, because these are the denominators, not at all included. Denominator is not included. ठीक है? Clear? वन पे क्लोज इंटरवल विल बी देयर, है ना? ठीक है, चलो. Now let's talk about two very very important things, that is stationary points and critical points. So stationary points are all those points. अरे संजय, factorization of cubic ना? So I just did nothing. It is automatic. B square I have taken common. B minus 1 plus 1 B minus 1. Now take B minus 1 overall common. It will be B square plus 1. This is what I did. है ना? Factorization of cubic. I hope that this is fine. ठीक है. Now there are two important terms when it comes to maxima and minima. Number one is stationary points. Number two is critical points. Stationary points are those points when your derivative is equal to 0. Critical points are all those points where either f dash x is 0 or f dash x does not exist. Now this is the Indian thing, है ना? Indian thing. This is a US thing. Stationary points, usually we do not use that term. Critical points is something which is the Indian thing, right? So f dash as equals to 0 is also a critical point. Some people forget. F dash as does not exist is also a critical point. This is a very important point. Especially those 10% of questions some people will not be able to do. They only know f dash as x equals to 0. Okay, for example, suppose we are having a function fx equals to this. Can we find critical points right here? So f dash x, let's find f dash x and make it 0. 3x square minus 12x minus 36. 3 if I take common, x square minus 3 4s are 12 minus 6. ठीक है? Correct है ना? 3 1s are 3, 12. हाँ. So x square minus 4x minus 12. So now 12 will be 6. हाँ. X minus 6 and x plus 2 equals to 0. What are critical points? Minus 2 comma 6. Minus 2 comma 6 are critical points. Very easy peasy lemon squeezy. Okay. All right. All the best, Manika. All the best. All the best. ठीक है? So both stationary. So x equals to minus 2 and 6 because f dash is 0. So this is stationary point and it is critical point as well. Right? Okay. Now again, we have another thing. Now this is very important. Understand it nicely. Fx equals to x minus 1 raised to power 2 by 3. Now differentiate it. Right? So differentiate f dash x. Tell me. So this is 2 by 3 x minus 1. 2 by 3 minus 1. So minus 1 by 3. Now hold on. Because there will be some students who will be telling me that ma'am x equals to 1 is critical point and stationary point. No. Okay. Understand. This is actually 2 by 3 x minus 1 raised to power 1 by 3. So f dash 1 is not defined or does not exist. So this is not at all a stationary point. It is only a critical point. There is no stationary point, right? Huh. So basically x equals to... Oh, sorry. Sorry, I have actually missed this x. F dash x. Let me redo it. So x minus 1 is constant, minus 1 by 3 plus. This time x की power 2 by 3 will remain as it is and x minus 1 derivative is 1. So if you solve it, what will you get? X minus 1, 2 by 3, x की power 1 by 3 plus x raised to power 2 by 3. Let's take LCM, है ना? So 3x की power 1 by 3, then 2x minus 1, then plus we have 3x. So this is going to become what? 2x. So this is 5x minus 1 upon 3x की power 1 by 3. Right. So now, if I talk about f dash x equals to 0, so this is happening at x equals to 1 by 5. That is stationary point and critical point both. But f dash x does not exist is happening at x equals to 0. That means this is critical point. So that means critical points are both the points 2 by 5 comma 0. 2 by 5 pe derivative is 0 and x equals to 0 pe we have not defined. But stationary points are happening only at 2 by 5. Okay. Alright. And one more thing, let me tell you that what is happening. Whenever we say na f dash x is like the denominator is becoming infinity. What does that mean? That slope is infinity. That means we have a vertical tangent. Vertical tangent. Vertical tangent. Okay. Alright. Now, so now till now what we have done is we have understood actually what is local maxima, what is local minima, what are stationary, what are critical points. Now, why I have introduced stationary and critical points, specifically critical points, because it will help us in understanding the first derivative test. First derivative test will help us to know application of derivatives whether the function has maxima or minima. Okay, the first derivative test. What we will do is we will find out all the points where my f dash x is becoming 0 or not defined. So basically, the moment I need to find out point of maxima or point of minima, the first step would be finding the critical points, which we have already like done some exercise, right? Find the critical points. The critical points, what are critical points? Critical points are potential candidate of becoming a local maxima or local minima. Okay. Alright. So once you have listed down the critical points, now one by one you can like execute the process. You can understand the process and then tell, acha, out of these critical points, this is local maxima, this is local minima, and this is nothing, neither minima, neither maxima. Okay. So how will it happen? So first of all, critical point, step number 1. Now the moment you get derivative equal to 0, suppose at x equals to 3, what you will do, that you have already done by the way, that you have to know the neighborhood of x equals to 3, the left and right. Okay. So if from left to right, the sign changes from minus to positive, negative to positive. That means you are having a minima. Yes, this is the case. You are having a minima. So negative to positive, if sign is changing, you are having a minima. If positive to negative is changing, you are having a maxima. So negative to positive, minima. Remember, negative to positive, minima. Okay. And the otherwise, that means positive to negative will be maxima. For example, fx equals to x square. So now by the diagram only we can know that this is a minimum. But how will we use the first derivative test? Let us understand. Suppose fx is given. Now you have to differentiate. F dash x will be 2x. So f dash x equals to 0. That means 2x equals to 0. So x equals to 0 is critical point. By the way, this is a potential candidate of becoming a point of local maxima or minima. Okay? Point of local maxima or minima. Now x equals to 0. ठीक है, अभी 0 के लेफ्ट में, तो 0 के लेफ्ट में this is f dash x. So left hand side of 0, that means the moment you put negative x, you are going to get negative f dash x. That means leftward it is negative, rightwards, so if you put positive, like to the right of 0, if you put any positive number over here, right of 0, so you will get a positive quantity. So negative to positive, sign changes from negative to positive, that means you have a minima. And also understand that if f dash x is negative, the graph is decreasing. If dash x is positive, graph is increasing. That's why it is becoming a minima. So minima means Decreasing to increasing is actually a minima, right? From negative to positive, that's why minima. I hope that this is clear, right? And now the same thing. Now positive to negative will be a maxima. Okay, the positive to negative will be a maxima. So suppose you are having sin x, okay? So sin x पे 0 to pi में you have to understand what is happening, है ना? Whether there is maxima or not. First of all, differentiate and equate it to 0. So ma'am, okay. First of all, sin x graph is this. We know that this is maxima. And obviously, this is increasing. So derivative is positive. Decreasing derivative is negative. Derivative. So differentiate cos x, f dash x, right? It is becoming 0 at x equals cos x. When cos x is 0 at 90 degree, right? It is 0 at 90 degree. Now pi by 2. Now you put a value which is greater than pi by 2. That means you are going in second quadrant. Second quadrant mein cos x is negative. So f dash pi by 2 plus is negative. F dash pi by 2 minus is positive. So that means it is going from positive to negative. So it is a maxima. Positive to negative means increasing then decreasing. So there will be a maxima. Okay. All right. Clear? But ma'am, hold on. Okay. Okay. You are saying if minus to plus, then it is minima. Plus to minus, it is maxima. What will happen if the sign doesn't even change? That before also sign is changing, before also sign is positive, after also sign is positive. Let me tell you that what I am trying to say. Suppose we have an example, fx is equals to x cube, right? So differentiate. Okay, hold on. Let us differentiate f dash x equals to 3x square. So it is becoming 0 at x equals to 0. So x equals to 0 is critical point. This is a potential candidate of local maxima or minima. Doesn't mean that this is having a local maxima or local minima. Now, okay, so ma'am has told us x equals to 0 पे 0 आ रहा है. The moment you get f dash x equals to 0, check the neighborhood. Check the sign of the neighborhood, right? Okay. So f dash 0 plus. If you put right hand side of 0, f dash 0 plus. So it is a positive. Basically, 3x square can never be negative. So if you go right side of, so 0 पे f dash 0 is 0. Right side पे positive, left side पे positive. If the sign is not changing, then there is not maxima and not minima. Neither maxima nor minima. Then ma'am, what is it? So it is actually point of inflection. Yes, this is a point of inflection. If the sign is not changing, then it is point of inflection. So whether both the sides are like this time, both the sign is positive. Even if both the sign on the left hand side of the derivative is negative, then also it's a point of inflection. है ना? Okay. We'll understand point of inflection in detail, by the way. ठीक है? चलो. हाँ, अभी points of extrema, if somebody has asked us to calculate point of extrema. So f dash x. So there are two functions involved. So let's keep x square constant. Derivative of this will be twice x minus 2 plus. This time x minus 2 square will be constant and this is 2x. Correct? F dash x will be 2x, so can be taken common. X minus 2 also can be taken common and inside the bracket. So x minus 2 is gone. 2 is gone. So x will be there plus 2x is gone. X minus 2 is gone. X minus 2. So this is 2x, x minus 2 and 2x minus 2. So 4x, x minus 1, x minus 2 is your f dash x. Now just tell me f dash x is equals to 0 at x equals to 0, 1, 2. These are the critical points. That means there are 3 potential candidates for maxima and minima. Right? Okay. Now, wavy curve method. Okay. So plot the number line. Now just tell me that the sign of f dash x just after 2 will be positive. Just before 2 negative, positive, negative. ठीक है, so positive after 2, so this is the derivative sign. The derivative is positive, we have an increasing function. Derivative negative, we have a decreasing function. Increasing function, decreasing function. This is a rough thing so that we see that what is happening. So can you see x equals to 0 पे minima है, local minima, and this is local maxima, local minima. Okay, so basically critical points तो we have calculated, ठीक है ना? So minima, maxima, minima. Finally local maxima at x equals to 1, local minima at x equals to 0, 2, right? So the graph of this function, if I try to plot now, it will look like this. So decreasing, see, decreasing, sorry, decreasing ऐसे थोड़ी होता है, decreasing, increasing, decreasing, increasing. Just tell me that global maxima, so it is not, will not exist. Global maxima not exist. What about global minima? So obviously this is minima, maxima and minima, right? Global maxima so is it's like infinity value. But what about local global minima? So global minima can occur at either at this point or this point. That we need to check. है ना? So we need to check. There is a competition between 0 and 2. So just tell me f of 0 is what? 0. And f of 2 is what? 0. Okay. Alright. So global, so both are sharing same value. That means both are having global minima. Both are having global minima in this particular case. Bolo, clear or not? Clear? Alright. Chalo. Let us move on to the next problem, which was JEE Main April attempt 2019. Okay? So question is saying that S1 and S2 are respectively the sets of local minimum and local maximum. Okay, S1 is minimum, S2 is maximum points of the function. Okay, so this is the function. And I understand local minimum points, not the local minimum value. Okay. So now f dash x, let's differentiate. F dash x will be equals to 9 4s are 36 plus 36. Sorry. F dash x will be equal to 36x cube plus 36x square minus 72x plus 0. 36 if taken common, and x also if taken common, x square plus x minus 2. This is your f dash x. F dash x. Okay, right? Then, so now just f dash x, finally 36x, and this is x plus 2, x minus 1. Okay, so now just tell me critical points. X equals to 0, 1, minus 2. Now what we will do is the wavy curve method. We'll plot these three critical points on the number line. Okay. So minus 2, 0 and 1. Obviously minus 2 will be the leftmost, then 0, then 1. Now this is very obvious that this sign will be a positive, then it will be a negative, then it will be a positive, then it will be a negative wavy curve method. Okay. So clearly if I just try to plot the graph, this is decreasing area. Decreasing area looks like coming down. Increasing, that means going up. Decreasing going down. Increasing coming up. Okay. So this x equals to minus 2 is minima. And x equals to 1 will be again minima. So minus 2 comma 1 is S1. Minus 2 comma 1 will be S1. Okay, and S2 will be, obviously this is maxima. So this option C is absolutely right. Okay. Option C. Absolutely right. Yes, Sanjay, correct. All right. Yes. Now let us talk about the next problem, which is this. Okay. Okay. All right. The set of all real values of lambda for which the function fx equals to this has exactly one maxima and one minima. Okay, so basically they want, so f dash should be equal to 0 at exactly 2 points. That's what they want. Okay, chalo, so differentiate now f dash x. First of all, fx ko let me write 1 minus cos square can be written down as sin square x, lambda plus sin x. Okay, so this is sin square x lambda plus sin cube x. I can write it this way also. This is your fx. Now let me differentiate f dash x will be equals to 2 sin x cos x, lambda is already there, plus 3 sin square x cos x. Can I take something common? Sin x can be taken common. Cos x also can be taken common. 2 lambda plus sin x will be here. And this I need to equate it to 0, f dash x. Please mind that the interval we are having is minus pi by 2 open to pi by 2 open. So sin x, if you want to make sin x 0, 1 by 1, sin x equals to 0 implies x equals to 0. So first critical point I have obtained. Cos x equals to 0 implies x is equals to null. Why? Because cos x becomes 0 at pi by 2. That means this is not giving me a critical point. So this should definitely give me a critical point, because for having one maxima and one minima, I should have two critical points, my dear students. So this is going to become lambda plus sin x equals to 0 should give me 2 lambda, sorry. So sin x, sorry, this is 3, right? 2 plus 3, correct? 2 plus 3. So sin x should be equals to minus 2 lambda by 3. Okay. Sin x is equals to minus 2 lambda by 3. Now this should give me one solution. Thank you, Sanjay. This should give me one solution. For this to become 0, minus 2 lambda by 3 should lie between minus 1 to 1. Yes or no? So that means minus 2 lambda should belong to minus 3 to 3, and lambda should belong to minus 3 by 2 to plus 3 by 2. So clearly this should be your lambda, and also because minus pi by 2 and pi by 2 is not, minus pi by 2 and pi by 2 is not included. That's why we have an open bracket, open bracket, open bracket, open, open, open. So this is the answer, option C. Also one more thing, hold on. Option C is not even correct. Please understand, this is a tricky question. Hold on. Arre. Where is eraser gone? Hold on. Basically, what we are looking for is, we are looking for two critical points, yes or no? Okay. So first critical point is x equals to 0. Second critical point I should get from here. So sin x should be equals to minus 2 lambda by 3, and it should not be equal to 0, because I don't want to repeat my critical point over here. I do not want to repeat my critical point, right? Because sin x is already 0. If lambda becomes 0, then we are again having the same thing. That means we will be having single critical point. But in the question, they have already mentioned they want one maxima and one minima. That means two critical points we need. Clearly two critical points. The lambda cannot be 0. So the value of lambda cannot be 0. That means B and C both are wrong, definitely. Right away, we can say it on the face. And also minus 2 lambda by 3 should belong to minus 1 to 1 open bracket. So that's why option D will be absolutely right. Just tell me if this is clear to you guys. Okay. Now, before jumping on to the second derivative test, let's do one more question on the first derivative test. And so what we are doing is first derivative test. Okay. first derivative we are applying. Let's do it over here as well. And then second derivative test is actually not like, it is fine, but all the problems can be solved with the help of first derivative. You don't need the second derivative test, especially in JEE main. Okay, but we will still study the elementary part just so that when you get stuck, so you have both the methods, first and second both. But majority you have to apply first. When you are like frustrated with the first method, you can use second method as an alternative method. Okay. Maximum value of the function on the set this. Acha. The maximum value we need to find out on this set. That means first we will solve this. है ना? X square minus 11x plus 30 less than or equals to 0. है ना? So just splitting the middle term, can we do that? 5 6 are 30. 5 plus x is 11. X minus 5, x minus 6 less than or equals to 0. X belongs to 5 to 6 by method of intervals. That means we have to understand this cubic polynomial in this interval only. That's it. Okay. Hi Gina. Thank you so much Gina. है ना? So now fx. So fx is given f dash x. 3 3 is a 9x square minus 36x plus 27. F dash x equals to 9 common. X square minus 4x plus 3. So 9 x minus 1 x minus 3. 1 and 3 are critical points. 1 and 3 are critical points. Right now this is a cubic polynomial with leading coefficient positive. Do you know how does a graph of cubic polynomial look like with leading coefficient positive? It looks like this. है ना? Minus infinity to plus infinity. Now 1 and 3 are critical points. So obviously at x equals to 1 I'm gonna get maxima and 3 pe minima. This is how the graph is. And here 5 and 6 will come. So clearly if I talk about 5 to 6, okay, so the graph between 5 to 6, because I am only concerned about between what is happening between 5 to 6. So clearly 5 to 6 mein this function is increasing, hai na? So now if I talk about in this interval, fx is increasing. So if you are talking about the maximum value of the function in this interval, so obviously it will lie at x equals to 3. So maximum value is f of 6. F of 6 you have to find out, that's it. F of 6 equals to 3.6 cube minus 18.6 square plus 27 into 6 minus 40. So 2 and 6, 3 into, or what we can do is 6 I can take common. No, it is easier to take 6 common. 6 is a 6 cube if I take common. 3 minus 6 square is gone. Hai? Hi. 6 3 is 18. So 3 minus 3. So this is, these two are getting cancelled out. No? 27 into 6. So now you solve it. 6 7s are 42. 4 carry. 6 2s are 12. 12 plus 4, 162 minus 40. This will be your answer. So 122. Option C. है ना? Okay. Gina is asking, where is the treat for Teachers Day? Here is the treat. Treat is going on. You don't feel this like a treat? This is a treat. All these things are treat to watch. Don't you think? Chalo. So before, so now first derivative test, so we have done so many problems. है ना? ठीक है? So this is done already. Now second derivative test. Let us quickly talk about the second derivative test. है ना? Second derivative test. Yes. Last thing. है ना? Second and then nth. नहीं. I don't know Tamil. No, this is not cheating. How come this is cheating? Huh? Chalo, second derivative test में we need to like same thing. The beginning part is same. Okay. So what we need to do is we need to calculate the critical points. है ना? But again, the function should be continuous and differentiable. If it is not, then go with another method, graphical, and do some shit. Okay, है ना? So if a function fx is continuous and differentiable, then find out the critical points. Now all those critical points पे you have to find double derivative. Yeah, right? So if double derivative at all those critical point is positive, that means you are having a minima, because double derivative positive means concave upwards. Okay, so basically double derivative always tells about the concavity. So if double derivative is positive, that means your graph is concave up, that means you are going to get a minima. But if double derivative is less than 0, right? So concave up. If double derivative is less than 0, basically, then you are going to get a maxima, that means concave down. Concave down. Right? Okay, concave down. Clear? Any doubts? Any confusion? Okay. So now you have, okay. Now one more thing, you must be thinking that okay ma'am, f dash x equals to 0, get critical point. Now f double dash sign will tell you whether it is local maxima or minima. Got it. But what about your f double dash x equals to becomes 0? If double derivative becomes 0, then what will happen is you have to go for third derivative, fourth derivative, fifth, sixth, and till the time you get a non-zero quantity, na, tab tak you have to differentiate. I will tell you, do not worry. First of all, let's just execute the double derivative test. Okay, suppose you are having a cubic equation. Okay, so now what you will do is, whether you have to do it by the first derivative or second derivative, you have to differentiate it. So derivative 6x square minus 18x plus 12. Take 6 common. So it is going to be x square minus 3x plus 4 plus 2. Now just split. So this is your f dash x. Split, because critical points you're looking. So 1 and 2 are the critical points, obviously. 1 and 2 are the critical points, right? Now, first derivative test. Comparative study of first derivative test. So 1 and 2 are there. So 1 and 2. Because it is 6x minus 1. So again, wavy curve method say we will know positive, negative, positive. So again, increasing, decreasing, increasing. So clearly, x equals to 1 will have maxima and this will have minima. This is first derivative test. Points of extrema, got it. Second derivative test mein we have to double differentiate and now put x equals to 1. The moment you put x equals to 1, you will get a negative value, means maxima. Negative value, f double dash 1 is less than 0, that means maxima. F double dash 2, if you put 2 over here, you will get a positive value, that means minima. So that's how there is a comparison, right? So both methods, there is no need of second derivative, that's what I'm trying to say. Okay, so, but sometimes what happens is, first derivative test, you are not able to like get the sign of f dash x. Sometimes, like this is the wavy curve, no? Some functions have a different, it is easier to differentiate them second time rather than finding the sign in the slots. Okay, so in that case, remember second derivative, otherwise like there are very less chance of second derivative test. Okay, keep that in mind. Now okay, so again I was telling you na that second derivative test pe agar double derivative becomes 0, then what will you do? So very easy thing, because double derivative say you will understand whether it is maxima or minima, then you try to differentiate as many times as possible. Okay, so that we call it as nth derivative. That means you just keep on differentiating till you get non-zero quantity. Okay, so you differentiated f dash, so you just calculated the critical points, then double differentiated, put the value, again you're getting 0, you're not getting a sign. Then next time also differentiate, then differentiate, and then the moment you get non-zero quantity, now analyze that whether it is double derivative or triple or 4 times derivative pe you are getting 0, or like 5 times derivative pe you are getting 0. So if you are getting even derivative pe a non-zero quantity, even derivative pe you are getting a non-zero quantity. Suppose f4 dash 0 is f4 dash, f4 dash, fourth derivative पे you are getting a non-zero number. ठीक है, तो now you check the sign. If it is positive, then it is a minima. If it is a negative, then it is a maxima. Okay. If it is a 4 dash or 6 dash or 8 dash, basically the even derivative, double dash, 4 dash, 6 dash. Okay. So if that is non-zero, then positive pe again minima. You know it, right? Positive pe minima and negative pe maxima. Okay. So let's do one thing now. Let's just solve a question. You will realize that what I'm trying to say. Fx is given as this. Now you are trying to apply the second derivative test. F dash x. So 4x minus 3 ka cube. So critical points is x equals to 3. Correct? This is critical point. Now you are trying to apply the second derivative test, which says that you double differentiate and put x equals to 3. So double differentiation will be 12x minus 3 ka whole square. If you put x equals to 3, now double derivative becomes 0. Oh my god, that means double derivative is not working for us. If double derivative is positive, you are having minima. Double derivative is negative, you are getting a maxima. But it is coming out as 0. Then, now you keep on differentiating this. Triple derivative. So 24x minus 3. Again you are getting 0. F triple dash is also 0. Again differentiate it. So now the moment you differentiate it 4 times, that means odd number of derivative. Then you are having a positive, that means you are having a minima. Okay, so when even derivative pe you are getting a positive, then you will have minima. Even derivative pe if there is a positive, then there is a minima. Okay. So the graph of x minus 3 whole power 4 looks like this, obviously. And this is a minima, clearly. Okay. Okay. Chalo. Now, so this in the previous question, fourth derivative pe you got positive, right? What happens if you have gotten the derivative at fifth derivative? That means odd derivative pe. So if n is odd, then you are actually having point of inflection. Point of inflection. Okay. So understand what we started. Just tell me one thing. What happens if f dash 2 is positive? In the very beginning, we started with this. F dash 2 positive means what? F dash 2 positive means function is increasing, right? So that means f dash, single dash, that means if the derivative is odd, so you are having increasing. Okay. If derivative is odd, you are having increasing. If derivative is odd and greater than 0, increasing. Derivative is odd, less than 0, decreasing. That's it. So this we are already doing. You are not even aware about this. Right? So single derivative positive, triple derivative positive, 5 times derivative positive, all the things are increasing. If double derivative positive, f double dash, second derivative test. If double derivative positive, local minima, concave up. 4 times derivative positive, concave up. 6 times derivative positive, concave up. Now I guess it is connecting. Chalo, let's do one problem on this. 2x minus 1 whole cube. So let's try to apply second derivative test. Differentiate, calculate critical points. X equals to half is your critical point. Double differentiate to check whether it is maxima or minima. So f double dash half is equals to 0. Okay. So again 0, it is coming 0. F double dash half. Now one more time to triple dash. Okay. Hold on. Triple dash. Now triple dash. So f double dash, tell me. X will be what? So 6 to the 12. 2x minus 1. One more time if you differentiate. Triple dash x. That will be 24x. 24. That's it. 24. So this is positive. So f triple dash positive means what? If dash positive means increasing, triple dash positive will also mean increasing. Okay, but just that triple dash positive means point of inflection is also there. Okay, so no point of local extrema, is just that point of inflection at x equals to half will be definitely there. है ना? So I guess nth derivative test is also crystal clear. Okay, all right. Now let us understand the point of inflection. Last thing. Point of inflection basically is again that your triple derivative, right? So suppose y is equals to x cube. The first derivative, point of inflection means first derivative should be 0. At x equals to 0, we have point of inflection. So here in point of inflection, what happens is curvature, concavity changes. The graph changes its concavity. So this is concavity down, this is concavity up. So that's why it is a change in concavity gives you point of inflection. Okay. Now, fx equals to x cube, right? F dash x is 3x square. F dash x is 0 at x equals to 0, we know that. Now double dash, f double dash x is 6x. Now tell me, if you put 0, you will get 0. If you put a positive number, that means you are going to get positive. F double dash x positive means concavity upward as well. Concavity upward for positive x. Can you see, for positive x, we have a concavity upward. For negative x, concavity downward. So whenever f double dash x changes its sign, then also it is what? Right? Concavity changes means point of inflection. Okay. So yes, f double dash x changes its sign. That means it is a point of inflection. Okay. Okay. Chalo, this is sin x mein. Do we have point of inflection? So let us try. First of all, if dash x equals to 0, it will come here, but concavity is not getting changed. So this is not a point of inflection. So what about this? So again, now this is concavity upward, concavity downward. So yes, upward and downward. So 0 pe there is a point of inflection definitely. है ना? 0 pe there is a point of inflection. Pi pe bhi also same thing, point of inflection. 2 pi pe bhi also there is a point of inflection is there. है ना? So yes. So what happens? Curvature of the graph changes about that point. That is your point of inflection. So basically your if acha, so f double dash should change its sign. But in some cases, if f double dash becomes 0, then what to do? Then again same thing. You keep on differentiating. Then if f double dash is becoming 0, then try finding f 4 times dash 0. Okay. So f 4 times dash should change its sign. Okay. All right. So clearly this is point of inflection. X raised to power 4 is not at all point of inflection. है ना? तो f dash x is 0 at x equals to 0. Double dash is also becoming 0. Now what about triple dash? है ना? तो हाँ, f double dash is not changing its sign. Can you see here? F double, so x equals to 0 is doubtful point. Okay. So चलो ठीक है, let's do it, है ना? If x equals to y is equals to x की power 4 is given, है ना? Let me just talk and tell you. F dash x is what? Tell me. 3x cube. So what are critical points? X equals to 0 is the critical point. At this point, it may happen that we have a point of maxima, we have a point of minima. It can happen that it is an inflection point. So 3 things are possible here. Who will tell us? Nth derivative test. Keep on differentiating. F double dash x. This is, sorry, 4x cube है ना? हाँ, तो 12x square. Correct. So f double dash x is also 0. Now f triple dash x, tell me. So ma'am, this is 24x. Again 0. है ना? f 4 times dash x is 24. So 4 times. Tell me f double dash x becomes 0. That means minima. So f 4 times dash becomes positive. So it is also a minima. Right? So this is basically a minimum. Coming out as minimum. ठीक है? no inflection point. ठीक है. Now next, one last question. Let us do x raised to power 1 by 3 again. What we need to do is keep on differentiating. To differentiate, if I differentiate, what I get is f dash x 1 by 3 will come in front, and x power 1 by 3 minus 1 will be minus 2 by 3. So this will become what? Tell me. 1 by 3 x raised to power 2 by 3. ठीक है. So f dash is becoming not defined at x equals to 0. That means there is a vertical tangent at x equals to 0. So graph of this vertical tangent will look like this. So this is the graph. Vertical. So this is the graph. Just tell me. So point of inflection is there. By graph also we can understand. ठीक है. चलो. Graph से तो we can understand definitely. है ना? But if you want to differentiate one more time, then this is how it is. Double derivative is here. Okay. So double derivative will be minus 2 by 9 x raised to power 5 by 3. Now tell me. 5 by 3. So f double dash x is actually changing its sign. It is again not defined at x equals to 0. But it is changing its sign. Yes. If you put a positive number over here, it will become positive. 5 by 3 is an odd power, right? So if you put a positive number over here, so this will be a positive quantity, but negative sign is there. So f double dash x is changing its sign. If f double dash x changes sign, that means that it is a point of inflection. ठीक है? Gina is saying, how did you draw the graph? Okay, ठीक है. Very good question. ठीक है, just tell me, Gina, f dash x, we have just differentiated. Do you think f dash x is this? Yes, right? Now just tell me, the moment I put x equals to 0, what do I get? I get f dash x not defined. That means dy by dx. That is slope. Slope infinite at x equals to 0. That means, first of all, there is a vertical tangent. Okay, first thing. Second thing, just tell me that in here, because the power is even, na, x raised to power 1 by 3 ka square. So, apart from 0, whatever value you put here, it will always be positive. So, f dash x is always positive. That means the function is an increasing function. So, just that. Single critical point, overall function is an increasing function. So just tell me that this vertical tangent at x equals to 0, that means y-axis will be a vertical tangent increasing function. Obviously, it will look like this, increasing. 0 pe the value is 0. 0 pe value is 0. And now you have to increase in such a way. So there are multiple ways to increase. But vertical tangent, it should, y-axis should be a tangent. Again, y-axis should be a tangent. Now you just tell me that this thing is an increasing function or not. So that's how it is. That's how I plotted the curve. Hai na? So now if you connect all the dots, now you will be able to plot any graph in this thing. हाँ, अभी fx is equals to sin x, 0 to 2 pi. So sin x graph to we know already, right? So just tell me. First of all, critical point. Sin x graph is this. Critical points. Just tell me cos x. So cos x is 0. Critical points will be x equals to pi by 2 and 3 pi by 2. There are two critical points. Critical points are those points which tell you that these points can be potentially candidate for either local maxima or local minima or point of inflection. Okay. All right. So pi by 2 and 3 pi by 2. Now double derivative, f double dash x. ठीक है, and x equals to pi as well. Now pi critical point नहीं है, but pi we will check for pi as well, right? Pi, these two are critical points. ठीक है, तो डबल डेरिवेटिव इज बिकमिंग 0 at x equals to pi, right? So x equals to pi coming from here. ठीक है, तो f double dash x changes its sign. F double dash x changes is sin x. Sin x changes its sign around what? Sin x changes its sign around this pi, right? So that's why pi at x equals to pi, there will be a point of inflection. ठीक है, okay. So I guess we are done with today's session, and yes, all right. Last question on concavity. Let's do a last question on concavity. ठीक है, last. Find the intervals on concavity of this function. Also find the inflection point. Let's do that. So in this question, what we will do is, first of all, let's differentiate f of x. Right? Let's differentiate. So differentiate करोगे, तो this is your function, right? This is your function 4x cube minus 6 is 18x square. This is 216x plus 57. This is f dash x. Now, can I take something common? Can I just take something common from this? Not really. F dash x. Okay. So right now, so I cannot solve it. But double derivative. Okay. F double dash x. So 4 3s are 12. 18 2s are what? 18 2s are 36 minus 216. So if you take 12 common, this will be your f double dash x. Now f double dash x changes its sign when? Basically, they are talking about concavity, right? So concavity, so it is completely dependent on double derivative. Okay. Concavity will be dependent on double derivative. Lagrange's in upcoming lecture, Sanjay. Na? हाँ, double derivative में concavity we will check. So f dash we will not talk about it. ठीक है? So f double dash x. Just tell me 18 है ना? 6 3s are 18. So this is minus 6 and x plus 3, right? So this f double dash x is giving 0, 6 minus 3, right? So this is positive minus positive. F double dash x positive means concave up. So 6 onwards we are going to have concave up, minus means concave down, and this is concave up, right? Okay. And also minus 3 and 6 pe we are having change of sign as well, right? So concavity changes at minus 3 and 6. So these two are 2 points of inflection, and concavity upward is happening at minus infinity to minus 3 union 6 to infinity, and concavity downward happening at minus 3 to 6. 3 comma 6 pe f double dash changes its sign, hence it is a point of inflection. Okay. All right. Yes, Gina, asymptotes is there. Symmetry. What is like symmetry is a general thing, like symmetry of graphs. Are you talking about? So asymptotes we will be studying. I will be taking a curve sketching session. Okay. So curve sketching session will have that asymptote. Asymptote is nothing but, you know that like tan x graph, have you studied? Pi by 2 pe we do that dotted line. What is that? That is a tangent at infinity. Asymptote is tangent at infinity. So you have already seen that, right? Where? In cosec graph, in tan graph. So asymptotes we will study a curve sketching thing. Okay. Every point of inflection is a critical point, Sanjay is saying. Every point of inflection is a critical point. No, but not all critical points are POI. No. Sanjay, no. Every point of inflection is a critical point. No, because minus 3 pe, if you ask me, minus 3 is a critical point. So as per you, minus 3 pe f dash should be equal to 0, but it is not becoming 0. Are you getting my point? Because point of inflection, so yes, I agree that what you're trying to say something. Sometimes it happens that at critical point, sometimes it happens that critical point becomes point of inflection. That's it. Sometimes critical point turns into point of inflection, because critical points can lead to three things, either local maxima or local minima or point of inflection. Sometimes critical point just rule out local maxima cross, local minima cross, point of inflection tick. Sometimes there are chances that the list is not having a critical point, but other than that we are finding a point of inflection. For example, x equals to -3, it was not there in f dash x equals to 0, but we have found out it. Okay, double derivative. Okay, I guess we are done with today's session, and also we are running a biggest scholarship test. Okay, MVSAT. I hope that you are aware about it. If you're not aware about it, then what are you doing, guys? Know about it, right? Because MVSAT is that test which you can register and give it for completely free. Okay, so you can see that online test is going on. If you appear on these dates, that is 29 September, by this month end, be prepared, na, give it. I to see ki Gina is saying some motivation. I will give you motivation for appearing for MVSAT. Okay, just go and give a test and like understand that what is happening. You will gain some, like, you will see people around. You will see everybody is giving test. You will see, acha, like this we give tests. Unknown people will be there. Unknown faces will be there. So this is a mini JEE main experience if you want to make, na. So just I to suggest that go give it a try, है ना. So and you will see like JEE people around, the competition around. So that on JEE main day, na, you don't get anxious. Arey, so many unknown faces. What are we seeing? No, है ना. So try give like 1 or 2 days. I to feel ki you should go and do some testing and all, so that you find some people, ask them, है ना, and that's it, है ना. Then we are having online test also, 10 to 20 if you do not want to go. Okay, the online test is also there, so you can give this test as well. But I to feel you guys are always doing too much online. So I feel ki you should go here and give offline test, है ना. Although we have both the options. Hi Sachin, hello. Alright, so some motivation tip is, so my feeling is, the moment you get motivation, na, you just fix your schedule. You fix your schedule, you fix your discipline, because you know that motivation will go away in a few days, है ना. So the moment you get motivation, take full advantage of it, fix your schedule, fix your everything, so that when motivation goes, you are like, still discipline is still there, consistency is still there. That's what I believe in, है ना. Because on Monday तो I get motivation. Monday morning तो I'll be like, आज तो Namrata is going to kill. Okay, and by Tuesday I am like, Namrata is killed. But I use my Monday in such a way that if Monday goes smooth, na, then even if I don't have motivation on Tuesday, na, but my life is sorted. Okay, chalo. I guess this was all about from me. This is me, Namrata, signing off. And I know that indefinite integration you guys were asking for, so I have blocked my Sunday for you guys, specially for you. Okay, so Sunday ko 6 PM we are like indefinite integration, we are going to do it. And trust me, this session, indefinite integration, is going to be very, very important and really worth it. I am going to prepare left, right and center. I will share all the tricks possible. So my tomorrow, Friday and Saturday, I'll be preparing the lecture. Okay? Okay.